my dear students? Am I audible? Am I audible? Hello? Yes. Hello? Hello? Yes, guys. Hello, 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 hello. Hello, Oliva. Hello, Durga. Hello, Harshije. Hello, Oliva. Hello, Durga. Yeah, perfect. எங்க இருந்து அந்த சவுண்ட் வருதுன்னு தான் டவுட்டா இருந்தது. Yes, sir. Yes. So guys, named reaction evlo important nu theriyumla. So definitely named reaction la irundhu you can expect questions. Okay. So previous year questions ellame eduthu paatha ungalku theriyum named reaction is that much important. Okay, that much. So not only named reaction, we know that this mechanism is also important. Okay, so now we will think, yeah, named reaction only important. Not only named reaction, mechanism is also very, very important. Is it clear, Ada? Is it clear? Karichilla. I'm thinking, I'm karichilla. So, illa karichilla. Kantipan. So, guys, how are you? How are you all? So, எப்படி போகுது உங்களோட ப்ரிப்பரேஷன்ஸ் எல்லாமே? ப்ரிப்பரேஷன்ஸ் எல்லாம் சூப்பராக போகுதா? இல்லை நம்ம முடியலை மேம் அந்த ஃபீலா? Yes, I am going to teach mechanism first. Okay, so some mechanism is very important. Okay, for example, elimination reaction mechanism and SN1 SN2 mechanism is very, very, very important. So adu base pannite you should know like which one is SN1 reaction will follow, which one is SN2 reaction will follow. You can see lots of questions, lots of previous questions from the same content. Okay, from same content. Okay, so yeah, yes, HBU reaction, HPZ. Yeah, see, எனக்கு மட்டும்தான் இல்லை ஸ்க்ரீன் தெரியலையா? இஸ் இட் விசிபிள் இல்லைடா? விசிபிள் இடா? No. So today what I am going to teach is, I am going to teach first என்னடா? First topic we are covering today is like first reaction mechanism. Okay, reaction theriyudhu ma'am. Okay, reaction mechanism is very, very important. So reaction mechanism, then I will teach you rate of reaction. Okay, I will teach you rate of reaction and name reaction and practice. Okay, name reaction and practice. So I will give you one more session for named reaction. Okay, so ஏதாச்சும் named reaction miss பண்ணிருக்குனா இல்லனா டைம் கிடைக்கலனா, so I will give you one more session for named reaction and complete mechanismத்துக்கு. Okay, இப்போ mechanism SN1 உங்களுக்கு வேணும்னா, okay, so உங்களுக்கு வேணும்னா I will give you extra class. Okay, so extra class for mechanism. Okay, so எல்லா reactions ஓடியும் with included mechanism I will teach you. Okay, so உங்களோட NCERT ல என்ன இருக்கு, so we can follow that only. Okay, we can follow that. Okay guys, I think you all are ready. So everyone quickly smash the like button. Everyone quickly mark your attendance. Okay, quickly mark your attendance. Quickly mark your attendance. Like max to max 3 hours da. 3 hours I am expecting. So we can start. Okay, we can start from elimination reaction. Okay, from elimination reaction I am starting. Elimination reaction. So we know that when you consider elimination reaction, there is two type of elimination reaction. So one is E1 elimination reaction. Okay, E1 elimination reaction irukku, E2 elimination reaction irukku. Okay, E1 elimination reaction irukku, E2 elimination reaction irukku. So here you can see E2 dehydrohalogenation. Guys, what is dehydrohalogenation? What is the meaning of dehydrohalogenation? Solunga. What is the meaning of dehydrohalogenation? Dehydrohalogenation. Come on da. Come on da. It's very simple. Tell me what is D. D means dehydrohalogenation. What is the? Yes, removal of halogens. Dehydro. Here you can see hydro is also there. So H order elimination or removal. Okay, it is very simple. Okay, H order removal. Okay, that is actually dehydrohalogenation. Okay, dehydrohalogenation. That means here the removal of hydrohalogen. Okay, it's not removal of, I have seen H2O, no, not H2O. Listen the name, okay. So, listen the name carefully. Dehydrohalogenation, okay. Hydro na enna? It is H. Halogen na enna? X. So, dehydrohalogenation na enna? HX order elimination, okay. So, or we can say HX order removal, okay. That is actually dehydrohalogenation, daguta, okay. Settle. So, here this is also called beta elimination or alpha beta elimination, okay. It is also called beta elimination or alpha beta elimination, okay. So, here I will simply tell you your voice is low. Guys, ennoda voice low. Guys, ennoda voice low. Low irukka ma'am. I am late. No, you are not late. Now only we just started. Your voice is low. Really? Voice is low? Really? Hello? No, perfect ma'am. No, perfect ma'am. Illa ma'am. Audible. Okay da. So, just refresh pannunga. Okay. No, Kashifa, you are not late. Okay. So, first one is elimination reaction. So, adile E2 elimination reaction la what is I will tell you. Okay. I will tell you what is happening. Alkyl halide we are preparing alkene, okay. From alkyl halide, we are preparing alkene, okay. We are preparing alkene. So, I am writing here, I think it is visible. Alkyl halide we are preparing alkene. So, alkyl halide alkene prepare pannanum. Adha nammaloda aim. Okay, what is our aim? So, our aim is we are preparing alkene from alkyl halide. So, we can check kada. So, here you can see 1, 2, 3. 1, 2, 3. Okay. So, 3 carbon vachu illana 2 carbon vachu we can do here. Okay. So, here N irukku 1 carbon la halogen irukku and here it is hydrogen, and here also it is hydrogen is there, okay. So, what is happening? We are using a basic, okay, we are using a basic reagent, okay, we are using a basic reagent. So, here we are using reagents are very important, okay. When you consider reaction, reagent is that much important, okay. Reagent is that much important. So, here also the reagents are very important. So, here we are using reagent, okay. So, here we are using reagent like in basic reagent, okay, strong basic reagent. For example, we can take alcoholic NaOH, okay, alcoholic NaOH or KOH, okay, we can take it as we can take KOH also, okay, we can take, okay, or, okay, not alcoholic KOH and NaOH not together we are taking, we are separately taking either alcoholic KOH or NaOH, okay, alcoholic KOH edukala illana alcoholic NaOH edukala, okay, so you can take any one of the reagent, okay. So what will happen, enna nadakunda proper mechanism we are going to see, okay. So enna nadakku, so inge irundhu halogen poganum, okay, so என்னடா halogen இங்க இருந்து போகணும். So here என்ன நடக்கும்? So there is no intermediate formation here, okay. There is no intermediate formation. What does our intermediate means? Intermediate னா நமக்கு தெரியும் என்ன இருக்கு? கார்போகேட்டையான் இருக்கு, கார்பானியான் இருக்கு, கார்பன் free radicals இருக்கு. அப்ப இங்க intermediate form ஆகாது. That means there is no formation of carbocation, carbanion and carbon free radical, okay. there is no formation of carbocation, carbanion, carbon free radical. So then what you will get? You will get, so inga irundhu halogen, okay. So inga vandu I am writing normally base aanadanaala I am writing B, okay. I am writing B for base. So base enga vandu attack pannum? Base inga attack pannuma? Direct halogen attack panna mudiyuma? No. Because halogen contain lone pair, base also contain negative charge allada. So base will attack this hydrogen, okay. Base will attack this hydrogen. I am writing B minus, okay. That is our base, okay. So this will not happen, okay. This will not happen. I hope it's clear. So if it is not clear, just ask me. I will tell you 100 times, okay. I will tell you 100 times if it is not clear to you, okay. Puriyalana, I will tell you 100 times. No issue. Just ask, okay. Just ask. Open your mouth and ask, okay. So I know you can't open mouth. Just comment, okay. Just use your hands and type, okay. So yes. So what will happen da? Simple da. Inga irundhu இந்த bond break ஆகும், okay. இங்க இருந்து இந்த bond break ஆகும். Next என்ன நடக்கும்? Says this base will attack this hydrogen, okay. Here you can see a bond formation in between base and hydrogen. So you can see a bond formation in between base and hydrogen. So bond formation nadaku. Here you can see at the same time, okay guys, at the same time this halogen will lives from here, okay. Halogen inga irundhu pogum, okay. Halogen inga irundhu pogum, okay. Inga irundhu hydrogen, inga irundhu halogen pogum, inga irundhu hydrogen pogum. Base yara vandu attack pannum? Hydrogen vandu attack pannum. Clear? So I will tell you. So here you can see CC. So this bond is breaking, okay. So I will use another color, okay. Here you can see this is a hydrogen, this is a hydrogen, and here also hydrogen is there, here also hydrogen is there, and here you can see H. I want to write one more. Here also enna nadakunda? Here also you can see this bond is breaking, okay da? This bond is breaking. Here also another bond is forming, okay. So base hydrogen bond is forming, carbon hydrogen bond is breaking, and new double bond is forming. We want alkene allada. So now new double bond is forming, and here you can see C double bond X bond will break. I hope it's clear. Do you have any doubt, Ada? Any doubt? I can't see charts. Come on, charts is my energy, okay guys. I want to see charts. Charts are my energy. Guys, am I audible, Ada? Clear. Okay. Guys, charts are my energy, no doubt, Ada. Okay. So here I am going to write what is bond formation and bond breaking. So here you can see bond formation, okay. I am writing BF, okay, bond formation, and here you can see bond breaking. I am writing BB. Here this double bond is forming, okay. So BF, bond formation. Here this bond is breaking. So here you can see bond breaking, BB. Clear? Guys, is it clear? So it is not a, it is not a intermediate or something. It is a transition state. Okay guys, so we will say it is a transition state. I am going to write here transition state. Okay, is it clear? This is transition state. Correct, Ada? Clear, Ada? Perfect. So I am going to write the answer. Okay, I'm going to write the perfect product. Okay, so C double bond C, hydrogen is there here, another hydrogen, 1 2, here one hydrogen, and here also another hydrogen. You will get alkene, and you will get another product is BH. Okay, you will get BH also, and X will eliminate from here. I hope it's clear. Any doubt in this mechanism? I don't understand. Okay, I don't understand. Okay, Ramesh, I will tell you again. Okay, listen carefully. Okay, listen carefully, Ramesh. So it is actually, this method is actually, we will say elimination reaction. When you consider elimination reaction, you can see two type of elimination reaction, E1 and E2 elimination reaction. So in E1 elimination reaction, it is actually, sorry, E2 elimination reaction, it is actually dehydrohalogenation. Okay guys, listen carefully. It is dehydrohalogenation. What is dehydrohalogenation, ma'am? Okay, so dehydrohalogenation means it is the elimination or removal. D means here in chemistry, in chemical reaction we will use D means for the removal. Okay, so dehydrohalogenation means hydro means H, okay, halogen means X, so dehydrohalogenation means XH, okay, HX, okay, the elimination of HX. So what will be the product? So from alkyl halide we are making alkene. Okay, from alkyl halide we are making alkene. So we need a perfect reagent for this reaction. Okay, we need a perfect reagent for this reaction. So here you can see alcoholic KOH. Okay, alcoholic KOH is there, or alcoholic NaOH is there. Okay, we can use either. Okay, not we can use together alcoholic KOH, NaOH, not together. Either you can see alcoholic KOH or NaOH or RONAK. Okay, RONAK. Okay, so what you will get? You will get a transition state. Okay, this is the transition state. Okay, so this is your alpha carbon. Okay, so here you can see this is your alpha carbon. Alpha carbon means halogen is directly attached with the carbon, that we will say it is alpha carbon. Okay, alpha carbon, and this is beta carbon. So from alpha carbon this halogen will remove. Okay, so here from here this base, okay, this is actually we are using base, this base will attack this hydrogen, so here it will form double bond. Okay, now I think who told that, Ramesh, now clear? Ramesh, now clear? Ramesh, now clear or not? So everyone quickly smash the like button. Evlo likes I want 100 plus likes saddana venu, so 100 plus likes. Just a second, Dada. +100 likes. Okay. I want to see 100+ likes. Okay, so I hope it's clear. Ramesh, clear ma? Okay. So here you can see. So when you consider mechanism, okay, so mechanism important points are there. Okay, you should remember that points. Okay, you should remember that points. So here is the first point. Okay, here you can see our first point is which color should I take? Yellow. Okay. So no intermediate formation. No intermediate formation means there is no formation of cation, there is no formation of anion, there is no formation of carbon free radical. Okay, that is actually intermediate. Okay, so only transition state will formed. Okay, transition, you can see a transition state. So I already written here, this is our transition state. Okay, so we know that what is transition state from reactant to product. So there is a in between that there is a state. Okay, it's not a complete product or something, so it's a state. Okay, so yeah, so here you can see transition state, not intermediate formations. Okay, so next, all 5 atoms involved in TS are the same plane. Okay, so in this reaction, okay, in this reaction la involve pandra all 5 atoms should be in same plane. So which all 5 atoms, which all are that 5 atoms? So this base, okay, this base, hydrogen 1 2, this carbon and this carbon 1 2 3 4, and this halogen also. Okay, that 5 atoms should be in one plane. Okay, that 5 atoms should be in one plane. Okay da? Okay, that 5 atoms should be in one plane. Okay, next, rate of reaction with respect to Rx. Okay, rate of reaction with respect to Rx. So rate of reaction with respect to rate of reaction with respect to Rx. So Rx la namakku theriyum. Obviously, who will live first? Yaar first living group? Who is the living group ada? So yes, we know that iodine. Okay, iodine easier live pandu because bond is actually weak bond. So we can eliminate iodine in easily. Okay, we can eliminate iodine. So what will happen? Ri, RBr, RCl, RF. Okay, Ri, RBr, RCl, RF. Okay. Clear. So rate of reaction with respect to Rx. Okay. So rate of reaction with respect to Rx means another one is rate of reaction is directly proportional to stability of alkene. So how we will consider the stability of alkene? Which alkene is stable? How we will determine that? Yeah, this is stable alkene. This is not stable alkene. How we will say it is stable and unstable alkene? How we can say that? It is stable alkene. It is not stable alkene. How we will say that? How we will say that? It is stable alkene, it is unstable alkene. How we can say that it is stable and unstable? How we can say that it is stable and unstable? Come on. Good morning, Pooja. So tell me how we can identify which alkene is stable and unstable. It is very important. Okay, it is very important. Come on, para. Double bond conjugation. Any other double bond? So double bond is like that is only alkene allada. So double bond conjugation. Steric hindrance. Steric hindrance, no. So the thing is like number of, tell me number of, then you can say number of, different conditions are there, but we will consider this one also. Substitution, no. Yeah, that's, when you consider states of rule, yeah, we can say that, but then also that is not the first priority. Then also that is not a first priority. Carbon. So I will tell you guys, that is alpha hydrogen. Alpha hydrogen, number of alpha hydrogen we will consider. Number of alpha hydrogen is more means it is more stable. Okay, it is more stable if alpha hydrogen is more means. Okay, next is voice is low. Why? Hello da. Am I audible? Perfect allada. Now okay. So you should calculate the number of alpha hydrogen. Okay, if number of alpha hydrogen is more means obviously the stability is also more. Okay, so here you can see order. Okay, in reaction you can see base and this is reacting. Okay, base and this alkane is reacting. Okay, alkyl halide is reacting. So I can say that the order is 2. Okay, order is 2. Molecularity is also here 2. Elementary reaction. Okay, molecularity is also 2. Okay, then next one is more stable alkene is major product. Okay, more stable alkene is major product. Obviously like that only. So when you consider a chemical reaction, which product is more stable or which product is major, that is more stable. Or okay, so yes. Then next is anti-elimination. Guys, what is anti-elimination? What is anti-elimination? What is anti-elimination? So anti-elimination means here you can see there is a here you can see where is it equation? Yeah. So anti-elimination means it's not a direct attack or something, okay? It is not a direct attack. So this base is attacking hydrogen. So that elimination we will say anti-elimination, okay? That we will say anti-elimination, okay? That we will say anti-elimination. Third group, 1, 2, 3. So yes. So when you consider the rate of reaction, okay? Rate of reaction with respect to Rx. So Rx which rate of reaction compare பண்ணும்போது we know that iodine is a good living group, okay? Iodine is a good living group. So appo enna, it will live faster, okay? It will live faster, okay? It will live faster. Then bromine, because Rx bond is actually weak here, okay? Rx bond is actually weak here, so that is the reason, okay? That is the reason, okay? Got it? So if it is clear, tell me, Ada. Yeah, I hope it's clear. Third point, it's like Rx with respect to means Rx and Ri, it's in iode size is bigger size, so bond strength is also less, so easy angirindu pogum, okay? Okay, so rate of reaction is directly proportional to stability of alkene. At a stability of alkene, the number of alpha hydrogen is more means alkene stability is also more, okay? Alkene stability is also more if number of alpha hydrogen is more means, okay? So I will tell you in detail with the example, okay? Then next point, okay? This is another important point. In case of bulky base, okay? What is bulky base means? Here we are using KOH, NaOH, and also we are using RNAK, okay? RONAK, okay? RONAK. So what is bulky base means? Bulky base means tertiary alkoxide, okay? Tertiary alkoxide, okay? So here it is tertiary alkoxide. Here you can see oxygen is connected with the carbon it's connected with 3 other carbon, okay? So it is a bulky base, okay? It is a bulky, just a second. Yeah, it is a bulky base. So what is the product? Just assume what will be the product. What will be the product? So we know that. So it is very simple. So X ingirindu pogum, eliminate agum. So here you can see this is our alpha carbon, this is our beta, and this is also our beta, okay? So we can expect two product, okay? We can expect two product here, okay? Everyone quickly smash the like button. Everyone quickly smash the like button. So I want to see 100 plus likes, okay? 69 only. So here you can see it is alpha beta elimination, okay? I already told that it is also called alpha beta. Yes, very good, Durga. Yes. So what will be the product? So the product will be, you can see, so either double bond ingiyu irukala illana ingiyu irukala, okay? So here I am writing this is this one, and second product is this also, okay? Here you can expect two, okay? You can expect two what? Two product, because 2 alpha, 2 beta carbon is there, okay? 2 beta carbon is there. So inga venalo enna inga double bond ku attach agala, okay? Double bond varala. So which one is major product? Which one is major product? Which one is major product? How we will calculate which one is major product? In a photo to passport, postcard white lagudu ennada enakku puriyala. postcard white background, why blue? Ma'am, not one chapter. We are taking all the chemical reaction mechanism, named reaction, everything, okay? Not one chapter, okay? So this is actually very important for you. So yes, here you can see two product is there. My question is, which one is stable alkene? Which one is stable alkene? Which one is stable alkene? Major product. One, this is, I will write A, this is B. So which one is stable? So here you can see the major product is this, okay? Here the major product is this double bond, okay? Why? Because so it is a tertiary, it is a bulky group, okay? It is a bulky group. So bulky group varumbodhu, you can say that it is the major product, okay? It is the major product, okay? Okay, so I will tell you. So here you can see, in case of bulky group is attaching means, okay, bulky group is attaching means, here you can see less hindered, okay, less hindered, beta will decide major product, okay guys, less hindered beta, okay. Okay, less hindered beta. So, inga paranga, this is one beta, okay, this is another beta, okay, idhila less hindered, which beta is there, which beta is less hindered. So, less carbon irukkirathu, less hindered, okay. So, bulky group illa, okay, this is already one bulky group. So, less hindered nu solumbodhu, here you can see, inga ibdi varumbodhu, okay, in the beta consider, in the beta carbon consider பண்ணும்போது, here you can see one more group is there, okay, one more group is there. But when you consider this one, okay, when you consider this one, இங்க என்ன இருக்கு, இங்க வேற groups ஒன்னும் இல்ல, okay, இந்த beta carbon directly attach பண்ணி இருக்கிற வேற groups இல்ல. So இங்க என்ன, it is less hindered beta carbon, okay. It is less hindered beta carbon as compared to this one, okay. It is less hindered. So you can see double bond inga varum, okay, you can see double bond inga varum. Is it clear guys? Yes, according to base porthu we should check the product, okay. I hope it's clear guys. Any doubt? Guys, any doubt? Okay. Next we are moving to states of rule and Hofmann alkene, okay. We know that states of product irukku, Hofmann product irukku. What is states of product ada? States of product and Hofmann product. So here you can see this is a alkene, okay. So this is a alkyl halide, okay, this is a alkyl halide. So this alkyl halide is reacting with normal KOH, okay, alcoholic KOH. Then what will happen, Dada? So here you can see, yeah, we can also expect two products are there, okay. Here you can see this one product and this one product, okay. So when you consider which one is normally, states of rule means it is more substituted alpha carbon, okay. States of rule means it is more substituted alpha carbon, okay. So more substituted alpha carbon. When you consider this one, okay, inga idhula evlo alpha carbon irukku, idudha nammaloda double bonded carbons. So here you can see two alpha carbons are there, okay, two alpha carbons are there. So when you consider this one, one alpha carbon is there, okay, one alpha carbon is there. So one alpha carbon is there, so it is the minor product because one alpha carbon is there, one alpha carbon contain two alpha hydrogen, so it is contain 6 alpha hydrogen. 6 alpha hydrogen means it is more stable. But இங்க என்ன just alcoholic KOH மட்டும்தான் இருக்கு. Okay, alcoholic KOH தான் இருக்கு. So when you consider ஒரு bulky tertiary alkoxide இருக்கு. Okay, ஒரு bulky base இருந்தா major product minor product change ஆகும், and states of rule and Hofmannல change ஆகும் product. Is it clear guys? Clear ஆ? ஏதாச்சும் doubt இருக்கா? Clear ஆ? Is it clear? Okay, I will explain again. But it is, we are using normal KOH, okay, normal alcoholic KOH, okay. If you are using normal alcoholic KOH, so what will happen, Nada? If you are using normal alcoholic KOH means what will happen? So here you can see in a product, there is 2 product, Lada. So rendu product chance irukku, because it is also beta carbon, it is also beta carbon. Ingiyum double bond varala, illana ingiyum double bond varala. So I am writing two products, okay. So I want to identify which is, okay, which is more stable, okay, which is major product, okay. We know that more stable alkene is major product, okay. So which one is major product? So here you can see it contain 2 alpha carbon, here it contain 1 alpha carbon. Any doubt? 1 alpha carbon eppadi varudhu, 2 alpha carbon, this is a double bonded carbon. So here this is double bond attached பண்ணி இருக்கிற carbon na alpha carbon. So this is 1 alpha carbon, this is also 1 alpha carbon. So 2 alpha carbons are there. So this alpha carbon contain 3 hydrogen, this alpha carbon also contain 3 alpha hydrogen. So 6 alpha hydrogens are there, okay. 6 alpha hydrogens are there, and it is more stable guys, it is more stable, okay. So here you can see this is the minor product. 2 alpha hydrogen is there and less stable, okay, it is less stable. Clear? Clear? Batch class ஏதோ error இருக்குடா. I am trying to join ada, but ஏதோ like பிரஷ்னம். Okay, so you can join now, okay. So I thought I will take here, okay. So batch class la edo like some prashnam is there, so I thought I will join from here. Okay, so Gopika ma'am will do one like video, okay, other or video we are doing, okay. So no worries, okay. So idu clear dana, idu clear dana, edachu doubt iruka? So alcoholic KOH vanda eppadi product varum ellame clear dana? Okay, so yes. So next we are moving to assertion reason type of question. You can write the answer. So what is the answer of this question? Come on. Option C. Kashifa is saying option C, okay. Any other answers guys? Okay, I also don't know the answer. Assertion chlorobutane, okay, chlorobutane method. Chlorobutane on heating with the alcoholic KOH, okay. KOH What will be the product? We'll get two products. No, one product. Undergo dehydration, you will get butyronine. Yes. It is an elimination reaction involving carbonium ion intermediate. Are we getting any carbonium intermediate? Carbocation, carbanion or carbon free radical? No, nothing is there. Okay, da? We are getting. So it's a direct product. Okay, you can see a transition state. Okay, so there is no intermediate formation. You can directly see. So here you can see what is the correct answer. What is the correct answer? What is the correct answer? A is correct, incorrect. Yes, correct answer is C. Very good, guys. Yes, C is the correct answer. Okay, clear? Then we are moving to next question. You can write the question. Write the answer. Okay. So come on, quickly smash the like button, guys. Quickly smash the like button. There is a like actually Nambike batch la edo or error irundadunala. Okay, error irundadu adu automatically adu like entered ஆயிருக்குடா அதனால. Okay, அது ஏதோ. Yes, I also felt like that. So adanala I thought I will take YouTube class. Come on, quickly. Yes, ma'am, D. You guys are saying it's D. Let me check. Arrange the following alkyl halide in decreasing order of their rate of beta elimination. Okay. So what will happen, dada? What will happen to yes? So this is so I'm writing CH3 CH3 CH2Br. So here you can see double bond will form here. Double bond will form here. Okay, so this eliminate inga. Okay, so next one, double bond will form here. Here double bond will form here. Okay, choose the arrange the following alkyl halide in decreasing order of their rate. Okay, rate of beta elimination when alcoholic. Okay, so they are asking the rate. Okay da, rate da avanga kettadukku. So you should calculate like amme suprabhadam vaigiyadil chavikam hari hari ho hari hari. You're calling mummy me என்ன பார்த்து எப்படிடா மம்மின்னு கால் பண்ண ஃபீல் ஆயிடுச்சு. Yeah, so here we can calculate alpha. So this is the product allada. This is double bond CH2. This is the product. So guys, count the alpha carbon. Okay, count the alpha hydrogen. Okay, so we know that alpha hydrogen here is 6 alpha hydrogens are there. Okay, so here it is here evlo alpha hydrogen illa 0. Inga evlo alpha hydrogen irukku. Yes, here it is annada 2 inga 3 varum. So more stable A I can eliminate this. A after A C. Yes, correct answer is D, guys. Very good. Okay, then we are moving to next elimination reaction, that is E1. Okay, E1 dehydrohalogenation of alcohol. Okay, we are treating this reaction with the alcohol. Okay, so here you can see dehydrohalogenation. So tell me guys, what is dehydrohalogenation? What is dehydrohalogenation? Tell me, da. What is dehydrohalogenation? Tell me quickly in the chat box. Ennada dehydrohalogenation nu sollada. Dehydrohalogenation. Dehydrohalogenation. Removal of HX. Removal of HX. Dehydrohalogenation. Okay, of alcohol. So let's see what is this. Okay. This is not dehydrohalogenation, it's dehydration of water. H2O dehydration. Okay, dehydration of water. So there is a mistake. So this is not dehydrohalogenation. It is dehydration. Okay, dehydration. Okay, dehydration of alcohol. Okay, dehydration of alcohol. So guys, this is not dehydrohalogenation. Okay, dehydration of water. Okay, dehydration of water in alcohol. So here we are taking one alcohol. Okay, so I will write here only. Here I will write. Okay, this is actually I can't write. So just remember, this is removal of water. Okay, it is the removal of water. We are making double bond. Okay, so here from alcohol. Okay, from alcohol we are preparing alkene. We are preparing what I want to change color. So from alcohol we are preparing alkene. Adudha. Okay, so dehydration. Okay, dehydration. Okay, so dehydration. So E1 is at dehydration. Okay, just write dehydration. Okay, it's okay. So dehydration I will write here. Okay, இதுவும் கம்ப்ளீட்டா. ஓகே, ஸோ ஆல்கஹால்ல இருந்து we are going to prepare என்னடா ஆல்கீன். எப்படி ப்ரிப்பேர் பண்ணணும்? ஸோ இங்கே ஷோ பண்ண போதும்ல. ஸோ ஃபர்ஸ்ட் what will happen? ROH. ஓகே, இது நம்மளோட ஆல்கஹால். ஓகே, ஸோ ROH is reacting with என்ன H plus. ஃபர்ஸ்ட் ஸ்டெப்பு protonation. Guys, what is protonation? Dehydration. Yes. So guys, what is protonation? Guys, what is protonation? Hydration. Yes. D inga irukku. Okay, adanal I am not writing. Okay, so what is protonation? Tell me quickly, what is protonation? What is protonation? What is protonation? Adding proton. Yes, very good. So it is here what will happen? So hydrogen enga vandu add agum, OH மேல வந்து add ஆகும். So what you will get? So ROH2. In second step, what will happen? It's very simple. So it will eliminate. So what you will get? You will get a R plus. Okay, you will get R plus. So if rearrangement is possible, okay, if rearrangement is possible, so I am writing here rearrangement possible means you can possible. If rearrangement is possible, yeah, we know that which carbocation is more stable, tertiary, then secondary, then primary. Okay, so if rearrangement is possible, just do rearrangement, then we can write R in a double bond. Okay, you will get alkene. Okay, you will get alkene. You will get alkene. So okay, you will get alkene. Okay, clear? You will get alkene. Here also you will get alkene. Any doubt? You will get alkene. Alkene you will get H plus order. Okay. Is it clear? Is it clear or not? Is it clear or not? Is it clear, guys? Is it clear? Settle. Set. Yeah, no worries, I will give you examples. So before that, I want to share that here we know that some points, okay, if mechanism means there is some important points also we should cover, okay. If mechanism is there means there is some important point that we should cover, okay. So first one is formation of primary carbocation is the rate. Primary carbocation illada, formation of first carbocation, okay. So here I am changing, this is wrong, okay. First primary illa first carbocation. So before rearrangement carbocation, it's not primary carbocation, it's first carbocation. So formation of first carbocation is rate determining step, okay. So which step is rate determining step? So first step cation, rearrangement before carbocation formation. So that is actually rate determining step, okay. So next rearrange if possible, okay. So if rearrangement is possible means you can rearrange that, okay. We know that tertiary is more stable, then secondary, then primary, you can check alpha carbons, okay. And rate of reaction or reactivity directly proportional to stability of first carbocation, okay. Rate of reaction and reactivity, okay. So rate of reaction or reactivity is directly proportional to stability of first carbocation, okay. First carbocation. So next one, rate of reaction. What is rate of reaction? So rate of reaction is equal to K into R, because inga 2, okay. R irukku, OH irukku, okay. R irukku, H irukku, okay. So here I can write R minus, and this is the, okay, this intermediate form, okay. This is the intermediate form. This is actually a rate determining, rate of reaction determine பண்றது இப்படிதான், okay. So more stable alkene is the major product. Obviously more stable alkene is the major product only, okay. Then I will give you question, try that, okay. I will give you one question, you can try one question, okay. Come on guys. Hundred like side cha. 91. 100. Come on da. Ennada. Ma'am can't understand. So no worries. Just try. I'm saying that just try. Okay, I will tell you. I will explain. No worries. Okay. Okay. We can start. So I can see B, C. Okay, let me check. Okay. So here our reactant is OH. Okay. So what will happen? H will attack. So OH inga pogum. Okay. So carbocation will form. Okay, carbocation inga form agunda. So carbocation inga form agu. So I am writing the carbocation. Okay. It is visible dana. Carbocation is there. Okay, carbocation here, carbocation will form. So next what will happen if rearrangement is possible? Okay, if rearrangement is possible means rearrangement will happen. Okay, so let's check rearrangement possible or illaya. Tell me rearrangement possible or illaya. Here it is primary carbocation. Okay, So when you consider this one, inga carbocation vandirukku, yes, it is tertiary. So inga carbocation again rearrangement nadukkurudhu, so it is tertiary. Okay, so it is secondary, it is tertiary. Okay da, it is tertiary. So inga varumbodhu evlo alpha carbon irukku primary la, பிரைமரியில் எவ்வளோ ஆல்ஃபா கார்பன் இருக்குது, செகண்டரியில் எவ்வளோ ஆல்ஃபா கார்பன் இருக்குது, டெரிஷரியில் எவ்வளோ ஆல்ஃபா கார்பன் இருக்குது. ஸோ எல்லாமே ட்ரா பண்ணணும்னா ஐ வில் ட்ரா எவ்ரி திங். ஓகே, பிரைமரி, திஸ் இஸ் செகண்டரி, okay, this is primary, this is secondary, and this is tertiary. This is tertiary. So tell me, illada, there is some issue, there is some technical issue, so adanaala enakku join panna mudiyala. Okay, so so here you can say that how many alpha carbons are there. So yes, it is I will use another color. Yeah, so here you can see that this is a alpha carbon. So this alpha carbon contain 2 alpha hydrogen. So when you consider this one, so this contain 4 alpha hydrogen. When you consider this one, okay, this is not tertiary illa, so tertiary is this. I will draw. Okay, so when you consider tertiary, 1 2, this is 1 alpha carbon, 1 2, and this is 1 2, total 6 alpha hydrogen. So here rearrangement is possible. So this is the alpha, this is a carbocation. Okay, this is a carbocation because in a 6 alpha carbon hydrogens varudhu. Okay, 6 alpha hydrogen means it's more stable. Okay, rearrangement is possible. So double bond enga varunda, double bond enga varum. So inga vandalu double bond ku evada chance irukku, enga chance irukku. So this is one alpha carbon allada, not alpha, beta carbon. Beta carbon when you consider with the carbocation, so this is another beta carbon, this is also another beta carbon. So inga double bond vandalu, inga double bond vandalu similar da. So I will write here. Okay, so ingeyum double bond you can expect. Okay, we can expect here also, we can expect here also one double bond. Okay, so which one is more stable, this or this? Okay, which alkene is more stable? Again, okay, so again you should calculate the number of alpha hydrogen. Okay, again you should calculate the number of alpha hydrogen. Here it is 3, and inga varumbodhu evlo varuda, so idoda 1 2, and here also it is 1 2. So 1 2 3 4 5 6 7 alpha hydrogen is there. And if inga double bond vanda evlo enga varu, this is one carbon, so 1 2 3 4. Okay, 3 4 5 6. Okay, 5 6 tam varu, so less. So this is more stable. So this is more stable na. B is the answer ada. B is the answer. B is the answer. 1 2 3 4, yes, 5 6. Yes, this is the answer. C B is the answer. Is it clear? Ma'am, I can find alpha carbon, but how can I find alpha carbon and beta hydrogen, and how to give bond on structure? Is it clear or not? Ma'am, puriyala. Okay, I will tell you once again. So proper concentrate pannada. So here you can see this is our reactant. So what will happen? OH will eliminate. Okay, OH will eliminate, carbocation will form. Okay, so carbocation, if rearrangement is possible, okay, rearrangement is possible means rearrangement will happen. So it is primary carbocation, it is secondary carbocation, tertiary carbocation. Which carbocation is more stable? Obviously tertiary carbocation is more stable. Okay, tertiary carbocation is more stable. Listen carefully, tertiary carbocation is more stable. So I am writing here tertiary carbocation. Enga edudanu? So I am going to write the tertiary carbocation here. Okay, This is the tertiary carbocation. Guys, tertiary carbocation varaikum clear thana? Idu varaikum clear thana? Idu varaikum clear thana? Tell me guys, is it clear or not? Is it clear or not? Idu varaikum clear thana? Idu varaikum clear ah illaya? Yes. So next what will happen? Next what will happen? Double bond. We want double bond allada alcohol la irundhu alkene form aganum. Okay, alcohol la irundhu alkene form aganum. So where this double bond will form? Alpha beta. Okay, in between alpha beta. Okay, so there is two chance. Okay, there is two chance. So either this double bond will form, either this double bond will form, yes, either this double bond will form here or enga form agala, either this double bond will form here illana enna idudhan carbocation illa, so on either inga illana inga form agalam. Okay, inga form aanalu same da. Okay, inga form aanalu same da. So inga illana inga. So then what we should do? So which one is our major product? So we should find a major product. Major product is more stable. Okay, major product is more stable. So we should find a major product. Okay, yaar nammaloda major product. So yaar nammaloda major product. How we will calculate or how we will find out our major product? It is very simple. Just count the alpha hydrogen. Okay, just count a alpha hydrogen. So alpha hydrogen count pannalama. So this is our double bond. So this is one alpha hydrogen. Okay, this is one alpha hydrogen. So this is another alpha hydrogen and this is another alpha hydrogen. Okay, okay, clear? So in the alpha hydrogen you can see hydrogen, hydrogen, hydrogen 3. So in the alpha carbon mala you can see 2 alpha hydrogens are there. Here also it is 2. So total number of alpha hydrogen in this molecule, it is 3, 4, 5, 6, 7. 7 alpha hydrogen. Clear? So count the alpha hydrogen in this molecule. Okay, we can count together. So yes, this is alpha carbon. So this alpha carbon contain 2 alpha hydrogen. This is another alpha carbon. So this alpha carbon contain 2 hydrogen. So this is alpha. This is another alpha carbon. This also contain 2 hydrogen. So total 6 alpha hydrogen. So where you can see more alpha hydrogen in first molecule. Okay, in first molecule. So the first molecule is more stable. So this is more stable. Is it clear guys? Is it clear or not? So alpha hydrogen game da. Okay, alpha hydrogen game. Who's getting more alpha hydrogen? That is more stable. That will win. Okay, I have a doubt. My spectacles frame. Just like actually exam ku 2 hours munne ponga. Okay, munnadiye ponga. Okay, so just poi anga poi just show pannu. Okay, this is metal, so they will check and they will allow. Okay, so oru risk edukka venda, oru 2 hours munnadiye poi set agu. Okay, clear ada? Workspace, what is your name? I don't know your name. Tell me your name. Okay, so ஒரு 2 hours. ஸோ உங்களுக்கு ஏதாச்சும் பிரச்சனை இருந்தால் ஓகே மேபி நோஸ் பின்ஸ் என்ன மேம் அது என்ன லைக் என்ன அது ஓப்பன் ஆகலை டிஃபிகல்ட்டாக இருக்குது ஸ்டக்காக இருக்குது. ஸோ நோ வரிஸ். ஸோ யூ கேன் கோ. ஓகே, ஒரு 2 hours ஏர்லியராக போங்க. சடனாக போய் யாரோ பண்ணியிருக்கு ஜேஇ எக்ஸாமுக்கு ஜஸ்ட் டோர் க்ளோஸ் பண்ணுறதுக்கு 1 minute என்ன முன்னாடி போயிருக்கு. ஓகே, எஸ். ஸோ யார் விக்ரம்னு நினைக்கிறேன். விக்ரம் இல்லை, தருண் தக்ஷன் பேட்ச் ஸ்டூடெண்ட். ஸோ தக்ஷன் அப்படி போய் ஸோ ஜஸ்ட் என்ன ஜேஇ எக்ஸாமுக்கு ஜஸ்ட் என்ட்ரு ஆகுறதுக்கு கேட் க்ளோஸ் பண்ணுறதுக்கு 1 minute முன்னாடி முன்னாடி போயிருக்கு. எஸ். ஸோ நீங்கள் எப்போவுமே கொஞ்சம் ஏர்லியராக எனக்கு தெரியும் கொஞ்சம் ஸ்டூடெண்ட்ஸ்க்கெல்லாம் லேட் கம்மிங் சிண்ட்ரம்ஸ் இருக்கும். ஸோ ப்ளீஸ் டோன்ட் டூ தேட். ஓகே, ப்ளீஸ் டோன்ட் டூ தேட். இட் இஸ் யோர் என்ன வெரி இம்பார்ட்டன்ட் எக்ஸாம். இட்ஸ் வெரி இம்பார்ட்டன்ட் மீன்ஸ் இட்ஸ் வெரி இம்பார்ட்டன்ட். ஓகே, மெடிக்கல் சர்டிஃபிகேட் என்ன மெடிக்கல் சர்டிஃபிகேட்டடா? இதுக்கா ஸ்பெக்ஸுக்கா ஸோ நீங்கள் என்ன டேரெக்டாக ஒரு 2 hours ஏர்லியாக போங்க ஓகே ஏர்லியாக போய் செட் பண்ணுங்க ஓகே இது மாதிரி லைக் மேபி ரிலீஜியஸ் வேர்ஸ் எல்லாம் பண்ணுறவங்க எல்லாருமே கொஞ்சம் கேர்ஃபுல்லாக இருங்க லைக் டைம் அவ்வளோ லேக் பண்ணி லாஸ்ட் டைமில் அப்படி வேண்டாம் ஸோ நீங்கள் பேன் பாக்கெட் ஓகே பேன் பாக்கெட் ஸோ இஃப் யூ லைக் பாய்ஸுக்கெல்லாம் பேன் பாக்கெட் இல்லாமல் பேன் கிடைக்கிறது ரொம்ப லைக் ரேர் தான் ஸோ பேன் பாக்கெட் எம்டியாக இருக்கணும் ஓகே பேன் பாக்கெட் ஓகே அலவுட் ஓகே 2 pocketனா ஓகே யூ கேன் வேர் பட் இட் ஷுட் பி எம்டி ஓகே யுவர் பேன் பாக்கெட் ஷுட் பி எம்டி ஒரு பீஸ் ஆஃப் பேப்பர் கூட அங்கே இருக்க லைக் முடியாது ஓகே ஸோ இட் ஷுட் பி எம்டி யுவர் பேன் பாக்கெட் ஷுட் பி எம்டி Can we wear lens, ma'am? Why you are wearing lens, ada Sanjana? You are using like specs. So if you have specs use pannu. So don't take risk. Okay, take lens edutho lens edukala ungalku specs edukala avanga edu allowed pannirukana you can use that. Okay, what about coat pocket, ma'am? Coat pocket ada school uniform போட்டுட்டு எதுக்கு போணும்டா school uniform வேண்டா you can wear your வீட்டில் ஏதாச்சும் போட்டுற ட்ரெஸ் போட்டு போகே கேர்ள்ஸ் எல்லாமே we have like different type of pants allada so you can wear pants and pants la pockets buttons and zip okay இது எல்லாமே not allowed okay 2 hours na entry before நீங்க 11 o'clock ஆகும்போ அங்கே ரீச் போங்க ஓகே லைக் எதுக்கு அந்த லாஸ்ட் மினிட்ஸ் ஹரிபரி okay avoid that okay so in the last minute hurry எல்லாம் வரும்போது automatically your brain will so அது வேண்டாம் okay so then guys we are moving to next question so next question is here next question கொடுத்தா நீங்க confuse okay this one we discussed my mind dress for that really difficult I thought if it is uniform and uniform no எடா வீட்டில் எல்லாம் இருக்குல்ல ஸோ நம்ம லோவரல் யூஸ் பண்ணும்ல track pants so wear that so for girls it's very simple கேர்ள்ஸுக்கெல்லாம் என்ன பாக்கெட் இல்லாமல் lots of pants are available அடா and gym pant எல்லாம் இருக்குல்ல gym pant எல்லாம் பாக்கெட் இருக்காது okay you can use gym pant wear gym pant and gym dress போட்டு போங்க exam எழுதி வாங்க hijab ma'am will they give permission to wear hijab so exam apply பண்ணும்போது if you want to wear hijab so they will ask okay religious exam க்கு application இருந்த டைம்ல okay application இருந்த டைம்ல okay I got it okay எக்ஸாமுக்கு அப்ளிகேஷன் கொடுத்துருக்குல்ல ஸோ ஃபெப்ரவரி டைமில் ஸோ அந்த டைமில் நீங்கள் அப்ளை பண்ணும்போது அப்படி ஒரு ஸ்பெஷல் ஒரு ரிக்வெஸ்ட் அவங்க கேட்டிருக்கு உங்களுக்கு அப்படி ரிக்வெஸ்ட் இருந்திருக்குன்னா அப்போ கொடுக்கணும் நீங்கள் ஓகே அப்போ கொடுக்கணும் இப்போது ஐ திங்க் ஹிஜாப் இஸ் ஆல்சோ நாட் அலவுடு பட் இஃப் யூ வாண்ட் டு கோ லைக் ஏர்லியாக போங்க அப்போ அப்ளை பண்ணும்போது நீங்கள் ப்ராப்பராக அப்ளை பண்ணியிருக்குன்னா நோ இஷ்யூ ஸோ அப்போ அப்ளை பண்ணலைன்னா இப்போது கொஞ்சம் பிரச்சனையாகும் ஓகே ஓகே கிளியர் ஸோ நீங்கள் ஆல்ரெடி அப்ளை பண்ணும்போது ஹிஜாபுக்கெல்லாம் ஒரு ஆப்ஷன் இருக்குது ரிலீஜியஸ் வேருக்கு ஸோ நீங்கள் அதை அப்போ அப்ளை பண்ணும்போது கிளிக் பண்ணியிருக்குன்னா ஓகே இட் இஸ் அலவுடு ஓகே நோ இஷ்யூ ஸோ இல்லை நீங்கள் அப்போ அப்ளை பண்ணலைன்னா இப்போ முடியாது ஓகே ஸோ ப்ளீஸ் டெல் ஓகே vote ma'am you covered all reaction in this session please tell so I am trying to cover all the mechanism and reaction so I don't know how much I can cover so if I can't cover means I will give you another part 2 okay I will give you part 2 okay no worries okay chill okay then tell me the answer okay if I can't cover I will give you one more session okay so cover பண்ண முடியலனா I will give you one more session no issue ma'am dress dark colors na ma'am like dark pink ma'am dress dark colors na okay va dark colors na okay da romba floral prints already we did a video okay just go and watch that அது வாட்ச் பண்ணியிருக்கா அந்த வீடியோ. ஸோ வி டிட் எ ப்ராப்பர் என்ன அங்கே ஷாப்பில் போய் நாங்கள் என்ன வேர் பண்ண முடியும் என்ன வேர் பண்ண முடியாதுன்னு ப்ராப்பர் வீடியோ எடுத்திருக்கு. ஸோ ஜஸ்ட் போய் பாரு. ஓகேடா மேம். 3 and 4 சேமா? 3 and 4 சேமா? நோ, இட்ஸ் நாட் சேம். 3ல குளோரின் இல்லை, 4ல குளோரின் இருக்குது. 3 and 4 இஸ் நாட் சேமடா. A ma'am, illa ma'am, no point print ma'am, only plain dark pink. You can wear plain dark kurti, no issue. Ma'am, number 1 and 2, okay, number 1 and 2, okay, let me check. Okay, start pannalama. So I can see lots of answers here and doubts also. Guys, start pannalama. Guys, start பண்ணலாமா? Yes. So 100 likes ஆகல. It's so sad. Okay, yeah, start mom. Okay, what will happen? Yeah, this bond will break carbocation. This bond will break carbocation. This bond will break carbocation. This bond will also break carbocation. What is the question? The relativity order. Okay, relativity order of alcohol towards acid. Okay guys, here they ask the relativity order. Okay, order means actually rate of reaction they are asking. Okay, order of reaction. So here you can see that. So the rate determining step. Okay, which step is actually rate determining step? So I already told formation of carbocation step. Okay, formation of carbocation step, that means before rearrangement. Okay, so after rearrangement illa, before rearrangement is rate determining step. Okay, so rate determining step. Okay, so here you can calculate, yes, formation of carbocation step. So here what you can calculate number of alpha carbon. Okay, alpha hydrogen. Okay, so here we are calculating alpha hydrogen means, yes, here 1 alpha hydrogen, here it is 1 2 3 and here it is 4 alpha hydrogen, here it is here plus means here also it is 1 alpha hydrogen. So here also it is 1 here it is 1 alpha hydrogen, doubt. So 1 alpha hydrogen, there is a question lo oru prachana irukku. Oh, I missed one thing. Question la ingeyum 1 alpha hydrogen varudhu, ingeyum 1 alpha hydrogen varudhu, ingeyum 1 alpha hydrogen varudhilla. Okay, I will do one thing. Okay, here I am writing double bond is there. Okay, then try. Okay, I will try. Okay, there is a mistake in question. So here you can see 1 alpha hydrogen, 1 alpha hydrogen, 1 alpha hydrogen. So yes, so same you will get. Yes, actually 1 and 3 is actually same reactant allada. So here I am writing double bond. 1 and 2 is same. Oh, that you said. Oh no, that I don't. Okay, I got it. Now I got it. Now tell me the answer. Grace mark. I will give you grace mark. Okay, now I rectified the question allada. So try. Now you can try. Which one is, ma'am? 1 and 2 are same. Again 1 and 2 is same. Again in the 1 and 3 is same. Yeah, I changed that. So here you can see double bond is there. Now tell me the answer. Hamsini, Smita, Manju. Now no answer. No answer. So guys, here I can say that, here you can see that resonance is there and resonance. Okay, resonance is there. Positive, negative, double. Okay, positive, negative, double means you can see conjugation. Conjugation is there means resonance is there. Okay, so resonance is there. Resonance is there means it is more stable. Okay, resonance is there means it is more stable. So which one is more stable? So I can eliminate A, B, then I can eliminate A and B. Okay, so maybe D or C will be the correct answer. Then what should I do? Here, second one is the correct answer. Then after 3, second is the correct answer. Yeah, I can. This is the correct answer. Ma'am, your voice is too low. Oh my God. It's too low. Why? Why so? Clear, Ada? Clear? Okay, then we are moving to another important mechanism, that is SN1, SN2 mechanism. Okay, SN1 and SN2 mechanism. Guys, SN1 mechanism, what do you know about SN1 and SN2 mechanism, Ada? What do you know about SN1 and SN2 mechanism? What do you know about SN1 and SN2 mechanism? Come on, come on. 2 steps, 1 step. Which one is 2 step? Which one is 1 step? Yes, SN1 is actually 2 step. Okay, 2 step. So I will write your points here. Okay, 1 step. Okay, any other points? Slow and fast step. Okay, which one is slow and which one is fast step? Which one is slow and which one is fast step? 2 is 1 step. Okay, SN2 is 1 step. Okay, correct. 1 step. Here it is 2 step. Okay, any other point? Tell me. Substitution. Yes, substitution reaction. Yes. Together we can say it's substitution. We are substituting. Unimolecular. Yes, unimolecular and bimolecular. Okay, yes, nice. Any other points? I'm expecting more contribution from you guys. 1 slow. SN1 is slow. Okay, you guys are saying SN1 is slow and SN2 is faster. Okay, SN2 is fast. Okay, no ma'am, it's clear only. It is clear. Which one is clear? I'm asking your contribution. Okay, so I simply tell you. So, okay guys, this is Bunny and this is Sunny. Okay, this is Bunny and this is Sunny. So what is happening? Sunny is sleeping. Okay, then Sunny left. So Bunny Sunny oda place la vandu paduthiten. So enna Bunny adukapram varumbodhu enna Sunny adukapram varumbodhu Bunny inga paduthittu irukku. Okay, you can see. So in second one you can see that. So here Sunny is sleeping. What is happening? Bunny is coming. Okay, Bunny is coming and irritating him. Okay, Bunny is coming and irritating him. Bunny is here or not? Bunny is coming and irritating Sunny. So after that what happened? Sunny anga irundhu poirukku. Okay, so anga Bunny vandu paduthirukku. Okay, so in the same method da SN1 SN2 reaction la nadakudhu. Okay, same thing is happening in SN1 and SN2 reaction. So first we can discuss about SN1 reaction, that is unimolecular nucleophilic substitution reaction. Okay, it's a unimolecular nucleophilic substitution reaction. That is a SN1 reaction, guys. It is a SN1 reaction. Okay, so in SN1 we can say that it is 2 steps is there. Okay, here you can see 2 steps are there. Okay, so first so Bunny is living. Okay, sorry, Sunny is living. Okay, so upon the space vacant irukku. Okay, that is 1 step. Okay, vacant space is there. That is first step. In second step you can see that second step la yaru varudhu? Bunny varudhu. Okay, so 2 step method. Okay, 2 step method. So here you can see Rx. Okay, Rx. So rate determining step. Okay, why it is rate determining step? Because it's a slow step. Okay, it's a slow step. So here the elimination. Okay, so here the X group is living. Okay, X group is a living group. So it is Batman, ma'am. Okay, Batman, Superman. Okay, Batman, Superman, whatever you want, give the name. Okay. So what will happen, Dada? So here X will eliminate or X will live. Okay, it's a living group. Okay, so then what will happen? Here you can see carbocation will form. Okay, carbocation cation will form. In second, okay, nucleophile will attack this carbocation, okay, nucleophile will attack this carbocation. What is nucleophile? Nucleophile is, we know that nucleophile kitta enna irukkuda. So negative charge is there. That means lot of electron density is more in nucleophile. But in case of R minus, it's a electrophile. Electrophile means less electron density is there. So inge enna nadakudhu? Nucleophile is attacking this electrophile. Okay, it is a electrophile. So it loves electron. Okay, R plus loves electron. So here nucleophile will attack R plus. Okay, nucleophile will attack R plus. Then what will form? RNU. Okay, RNU will form. Clear? So I will write. I hope it's clear. Yeah, that I will tell you. Okay, polar protic, that I will tell you. So when you consider SN1 reaction also, there is some important points. Okay, when you consider mechanism means just check important points. Okay, important points in mechanism, it's very important. Okay, important points in mechanism is very, very important. Okay, so next enna nadakudada? Okay, we can check which all are the important points. Okay, so first one is carbocation intermediate formation. So carbocation intermediate will form. Okay, if rearrangement is possible, okay, if rearrangement is possible, rearrangement will also happens. Okay, if rearrangement is possible, so it will also occurs. Okay, so next step 1 is, okay, step 1 is rate determining step. Okay, rate determining step, and it is a slow step. Okay guys, it is a slow step. It is a rate determining step and it is a slow step. So it is a slow step. Okay, first step is a slow step, so it is a rate determining step. Chill. Then next one, rate of reaction with respect to halogen. So we know that here when you consider Ri, okay, so what is Ri? Ri, we will say it is a good living group, okay, because it has good living ability. Okay, why it has good living ability? The reason is the bond energy between Ri is less. Okay, bond energy between Ri is less. Why? Because the size of Ri is bigger size. Okay, when you consider the size with Br, Cl and F, the size of iodine is bigger size. Okay, so what will happen? We can easily break the bond. Okay, we can easily break the bond. So Ri, and after that Rbr, then Rcl, then Rf. Okay, then Rf. Then we are moving to next point, rate of reaction with respect to alkyl group. That is very simple. Rate of reaction is directly proportional to first carbocation. Okay, before rearrangement. Okay, before rearrangement carbocation. Next, rate of the reaction is equal to, so I told you rate in a first step la dhaan rate calculate panna mudiyum. This is the reactant. So what will happen? K into concentration of Rx1. Okay, so next is order. What is order? Order is equal to 1 and molecularity also 1. Okay, only one product reactant is there. Okay, so PPS, what is PPS? At a polar protic solvent. Okay, so this SN1 reaction favors in a polar protic solvent. Okay, polar protic solvent favors SN1 reaction. Okay, clear? Clear? If it is clear, I will tell you some more points. Then weak nucleophile, okay da? So here we are using nucleophile la. If it is, we are using weak nucleophile also. Weak nucleophile we can use because first what is happening? You can see a carbocation is forming allada. So carbocation is forming. So in a weak nucleophile analu, that nucleophile will attack that carbocation. Next is racemization occurs, retention and inversion. You can see retention product and inversion product, that I will tell you in detail. Okay, what is retention, what is inversion, that I will tell you in detail. Okay. Oh, I think I will draw. So here, what I written here, stereochemistry. So it is the stereochemistry of SN1 reaction. So I will write in another page, okay. Inside phenyl group, Br, methyl and hydrogen, okay. So it is reacting with, it's normally reacting. So what is that? It's our leaving group. So this is our leaving group. So who is our leaving group? Halogens. Okay, halogens are a leaving group. Okay, halogens are a living group. Clear? Halogens are a living group. Okay, halogen. Yeah, so this is the living group. So this is our living group. Then what will happen? 1, 2, 3. Okay. So here also you can see. Yeah. So this is our phenyl group. This is our H. This is our methyl group. I will use different color. So because inga irundha enna Br poirukilla, so obviously what is that? Vacant orbital is there. Okay. Different color paaka mudiyudha. Wedge bond and dash bond. Yeah, wedge bond and dash bond, but I can't write wedge bond and dash bond. It will take lots of time. So then what will happen? So next step la enna nadakkum? Next step la nucleophile will attack. Okay, nucleophile will attack. So which nucleophile we are taking here? Just nucleophile. Okay, so we are taking a nucleophile Nu. Okay, so just taking a nucleophile Nu. Just a second. Okay, yeah, I am taking a nucleophile Nu. Okay, it's not looking good. So yeah, this is Nu. Okay, so the nucleophile is Nu. Then what will happen? Yeah, obviously this nucleophile will attack. So obviously it is a carbocation. Yeah, what is this? This is a carbocation. Okay, this is a carbocation and this nucleophile will attack. Okay, this nucleophile will attack. So where you can, okay, what will be the product? So I am writing the product here. Okay guys, so I am writing the product here. So what will be the product? So here I am going to write the product. So first one is here you can see phenyl group. You can see phenyl group pH. I am writing here it is hydrogen, here it is methyl, and here it is a nucleophile. Okay, here it is a nucleophile. Okay, here it is a nucleophile. There is two chance. Okay, this is our product A. Okay, this is our product A. So I am writing there is one more product. So that is the product B only. So this is phenyl group and this is our hydrogen and this is our nucleophile and this is our methyl group. So what is the difference between these two products? 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 Tell me quickly. Tell me now, what is the difference between product A and product B? What is the difference between product A and product B? H and nucleophile, the position of H, hydrogen and nucleophile. So guys, here you can see the position of Br, okay. And the same Br order position la you can see nucleophile, okay. Same Br order position la you can see nucleophile here. This is actually retention product, okay. This is actually retention product, okay. This is actually retention product. And it is just opposite of this. Here you can see nucleophile. It is just opposite of this Br. Okay, this Br. This is actually inversion product. Okay, this is actually inversion product. Inversion product. Okay, this is retention and this is inversion product. Okay, this is retention and this is inversion product. Okay, clear? Retention and inversion. Okay da? Clear illa? Clear illa? Clear? retention and inversion. You can see retention product and inversion product. Yes. So opposite side la varudhu. So I will tell you the reason, okay, why this is happening. Okay. So here you can see, okay, before that I just want to add one more point. So normally we will think retention you will get 50%, inversion also you will get 50%. Okay, normally we will think, yeah, retention is 50%, inversion is also 50%. 50% da nama assume pannom, appadi alla. Okay, appadi alla. Okay, so actually inversion product is more than 50%. Okay, you will get inversion product more than 50%, like 51% normally we will consider. Okay, so retention product we will consider it is 49%. So I will tell you what is the reason for that. Okay, it is very important, that reason. Yes, very good, 49 and 51. So I will tell you what is the reason for that. Okay, I will tell you the reason. So here our nucleophile, okay, our nucleophile is attacking. Okay, our nucleophile is coming. So first enna inga irundhu bromine boron pogum. Okay, inga irundhu boron pogum. Okay, so boron pogumbodhu inga sollanuma I will tell you here. Okay, okay, inga irundhu enna achieved. Okay da. So then 150. Next target is there, 150. Okay, so here you can see Br. Okay, Br is a living group, boron. So boron enna inga irundhu pogum, bromine, bromine. Okay, so we know that bromine contain lone pair of electron. Okay, bromine contain lone pair of electron. Why I am saying boron? So bromine contain lone pair of electrons. So nucleophile is also negative charge. So bromine also contain lone pair of electron. So same side la vandu attack பண்ணும்போது what will happen, you can see. So inga irundhu boron ponadukku appuram da, but ponalum adu inga pakkathula da irukula. So same side la vandu attack பண்ணும்போது you can feel enna, you can feel illa, they can feel enna repulsion. Okay, because lone pair are there, negative charge is there. So what will happen, repulsion, you can see repulsion is there. Repulsion varumbodhu, so most of the time enna opposite side la irundhu attack pannum. Okay, opposite side la irundhu attack pannum. So this side. Okay, so instead of straight attack பண்றதுக்கு பதிலா you can see opposite side la irundhu attack pannum. So that's the reason we will say inversion product is more and retention product is less. So but less more means it's not a huge difference. Okay, it's not a huge difference, it's like more than 50%. Okay, you can see inversion product. Okay, it's like 51%. Okay, and it is 49%. Is it clear, guys? Is it clear? Is it clear? So the racemic mixture, I just want to add one more point. So the racemic mixture, what we will think, it's 100, it's not equal to 100. Okay, so retention, inversion. Okay, clear allada? Any doubt? Any doubt? Any doubt in this mechanism? Any doubt in this mechanism? Mechanismthila edachu doubt irukka? Clear. Okay, chill. Then we are moving to next SN2 reaction. Okay, SN2 reaction is just a single step reaction. Okay, it is a single step reaction. So here you can see RX. Okay, we know that halogen contain lone pair of electron. Okay, halogen contain lone pair of electron. Lone pair electron. Okay, so what will happen? So direct attack is not possible. Okay, so we know that nucleophile is a negative. Okay, and halogen also contain lone pair. So what you can see a backside attack, okay, backside attack, okay, you can see in backside attack. So front side attack is not possible, okay, because of this repulsion, okay, because of the repulsion. So you can see a transition state will you can see a transition state. Why? Because there is no carbocation, there is no intermediate formation. So it's a single step reaction, but transition states are there, okay, transition state is there. So you will get, this will be the product, nucleophile will attack, and there is no rearrangement also, there is no rearrangement, nothing, okay. I hope it's clear. Then I will give you questions. Before that, I just want to add some more points. I will add. So points of SN2 reaction, okay, these points are very important. So here transition states are formed, okay, transition state is formed, and first step is rate determining step, and it is a slow step, okay, it is a slow step, it is a rate determining step, okay. Yes, definitely I will upload this PDF. So if you watch this session only, then you will get to know, okay, yeah, this is the meaning, okay. If you are not watching this session, if you are downloading the PDF also, it's waste, okay, it will become waste, okay. So just focus the session. So I will finish this session around 3 o'clock, okay. So, and I will give you one break also, okay, I will give you one break at 1 o'clock, okay. Chill. So first step is rate determining step. Obviously it is a slow step, okay, so only one step is there. So first step is rate determining step, okay, and rate of reaction with respect to halogen is same only, Ri, after that RBr, RCl, RF, okay. So when you consider rate of reaction with respect to alkyl group, so rate of reaction is inversely proportional to steric hindrance. If steric hindrance is more, means rate of reaction is less, okay. Steric hindrance means lots of group, bulky group is there, means obviously what will happen, so the stability will also decreases. So primary is more stable, then secondary, then tertiary, okay. Next, so rate R is equal to K into Rx, two nucleophile, two reactants irukku, nucleophile irukku, Rx irukku. So that's the reason rate is, this is the equation. So order, what is the order? Order is 2 and molecularity is also 2. So I hope it's clear. I think a few more points are there. So it is a polar protic solvent. No, it is polar aprotic solvent, okay. SN1 is actually polar protic solvent, this is polar aprotic solvent, okay. And strong nucleophile we need. Why? Because here the nucleophile is attacking, okay. If you are taking a weak nucleophile, that attack will become weaker, okay. So we need strong nucleophile for this attack, okay. Inversion, Wander inversion, okay. What is Wander inversion means? You will get 100%, I will write, you will get 100% inversion product. You will get 100% inversion product, okay. Clear, Ada? Okay. Then we are moving to stoichiometry of SN2 reaction, okay. SN2 oda stoichiometry now we are going to check, okay. Okay. Yes. So here you can see stereochemistry of SN2, okay, stereochemistry of SN2. So here in a nucleophile is attacking in opposite side. So nucleophile is attacking in opposite side to halogen. So what will happen? You can see bond formation and bond breaking, okay, bond breaking and bond formation. So here halogen group will live. So 100% inversion product you will get. So that is actually Wander inversion, okay. Is it clear? Simple only, okay. It is simple only, okay. Clear enter. Come on, SN2. Yeah. So next, effect of solvent, okay, effect of solvent, okay. So there is two type of solvent. I just mentioned that polar protic solvent is there, polar aprotic solvent is there. What is polar protic solvent means? Obviously the dipole moment should not equal to 0, okay. But in case of polar aprotic solvent means the dipole moment is equal to 0, okay. Polar aprotic solvent, okay. Anga dipoles illa, negative positive charge difference illa, okay. So here dipole moment is not equal to 0, their dipole moment is equal to 0. So remove hydrogen from oxygen, okay, remove hydrogen from oxygen, and here you can see H2O and ROH and ROH, okay, and polar aprotic solvents are in acetone, dimethyl sulfoxide. இது எல்லாமே polar aprotic solvent க்கு example தான். Then இது வரைக்கும் clear தானடா? Then I will give you one question. You can do the question. So JE means question ada. JE means question da. Pakka clear. Okay. Tell me the answer. I will explain all these points again. Okay. Ma'am, options. Okay, you can say that option statement 1 is correct statement, I think. Did I add it? Statement 1 is correct, statement 2 is wrong. Abdi sonna podu. Okay, statement 1 is correct, statement 2 is also correct. So ebdina you can write it. So idu space illa, so adanala options edutha kadikkala. Hello Grishma. Good afternoon Jit. Okay. Okay, let me check it out. Okay. Pakalama. So statement 1, what is that? Okay. Will undergo SN1 reaction through primary halide. Okay. So what will happen? So ingerindi idu pogum. So carbocation will form. So we know that inge enna irukku, you can see that lone pair irukku. Okay, oxygen la we know that lone pair is there. So what will happen? Back bonding. Okay guys, back bonding will happen. Okay, SN1 reaction. So it will undergo SN1 reaction through its primary halide. Yes, it's correct only. Okay, back bond is there, so back bonding is there, so it is correct. Statement 2. So here you can see will not undergo SN2 reaction very easily through primary halide. So here I will tell you the reason. Okay, already discussed one point. So rate of reaction with respect to alkyl group. So with rate of reaction is directly proportional to 1 by steric hindrance. If steric hindrance is more means rate of reaction is less. Okay, rate of reaction is less. So here steric hindrance is more. Here steric hindrance is more. Okay, here steric hindrance is more. Okay, here you can see this is carbocation. Steric hindrance is more here. Okay, so it will not easy, okay, in SN2 reaction. So this is also correct. Okay, statement 1 and statement 2 is correct. Okay, yada, your message is visible only. Steric hindrance, very good. Steric hindrance is more here. Then I will give you one more question. Okay, do it. Steric hindrance is more. Come on. SS dude. Yeah. Come on, tell me, guys. SOL. What is that? What is that? Solvolysis. Solvolysis means it's nothing, it's like SN1 reaction la solvolysis nadakumla, so adinala. Okay, SN1 reaction. Where you can see solvolysis protic solvent la. Okay, so it is SN1 reaction. Durga is saying CBA. Okay, let me check. So B poirukku cation form aayirukku. So we can count the number of alpha hydrogens. So 1 2 3 1 2 1 2 3 5 6 7 alpha hydrogen. So here you can see idu ponadukku appuram what will happen? Positive charge, positive negative, positive single double. Resonance is there. Okay, resonance. One ring. Okay, one ring resonance is there. And here, idu ponadukku appuram positive charge, positive single double, positive single double. Two resonance. Okay, two ring resonance. Two ring resonance is there. So idu ponadukku appuram you can see positive is there. So carbocation will form 1 2 here also hydrogen 4 alpha hydrogen. So which one is more stable? Which one is more stable? Obviously C is more stable. Okay, C is more stable. C is more stable. Idila mattumda C illa. We can eliminate the sun. The C is more stable. After C B. After C B. After C B. Correct answer is B. Correct answer is B. Correct answer is B. Clear? Concept clear? Concept clear? Concept clear? Concept clear ada? Okay. Grishma clear. Concept clear ada? Concept clear ada? Engayache doubt irukka? Clear. Okay. Then we are moving to, I will give you another question then. Here is the question. JE means 2024 la vanda question da. JE means 2024 la vanda question. Okay. Do it. Come on, quick. Oh, you forget that was ascending order. Okay. You should be very careful. Okay. You should be very careful. Structure of major product. The following reaction is major product. AgCN. AgCN is a strong, okay, strong reaction, strong what? Strong nucleophile. So Ag plus and Cn minus will form. So we know that it is SN2 reaction. Okay, it is SN2 reaction. Okay, you guys are saying it's C. Let me check. Okay, da. Major product. Yeah. What will be the major product? It's very simple, allada. So iodine, chlorine, Cn. So what will happen? So AgCN. Okay, major product. Yes, major product is C only. Okay, C is the major product. What will happen? Br inga vandu attack pannu and NCN. Okay, that means nitrogen da inga direct bond varudhu. ஒரு சின்ன பிரச்சனை இருக்கு. Question actually you are saying it's like questionல இங்க Br is actually missing அடா. Br is missing. Br இருக்குல்ல அங்க தான் Cn வரும். இங்க Cn வரல. இங்க Cn வரல. இங்க Br வருது. Yes, அப்ப இதுதான் Br இங்க missing. Actually Br is missing. Grace mark. I will give you grace mark for this question, guys. I will give you grace mark for this question. Okay, no worries. Chill. I think option. No option illa. That question is wrong. So Br should be there. Okay. Option is wrong. No, question is wrong. So Br should be there. Okay da. So then I will give you another question. Your questions. I have lots of questions, I think. Okay, chill. So I will give you another question, guys. I think you all are ready for the next question. So the reverse. This is the slide, allada. Do it. So I told you nada, if I can't finish complete named reaction panna mudiyalena, I will give you one more session. Okay, I will give you part 2. Okay, I will give you one part 2 also. Okay, I will give you part 2 also. Identify the product A, B, C in the following. A, B, C you should. Okay, so what will happen? What is A? What is A da? What is A? What is A? What is A? We don't know. So anyway, so what will happen? So if it's react with the 1, 2, 3 here also, here it is. So here you can see carbocation will form allada. So next step in secondary it's there. So in next step what will happen? Yeah, Cl will attach here. So if you react with this AgCN, I think Cn will come there. Okay, Cn not Cn. So it will come NC. Okay, NC you will get. Okay, NC you will get. What will be the product? NC you will get. NC. I don't know. So what will be the product, da? What will be the product? What will be the product, da? What will be the product? Yes, very good. B is the product. Okay, B is the product. Clear alle? Clear? Okay. Then I will give you another question. Venuma illana I can move to next reaction. D. I will show D. This is D. But I will tell you one, two. Here it is, I will tell you the reason. Actually, cis product and trans product varudilla. So, adanala that B is the correct answer. Okay. Because of cis and trans. NC, CN. You should write CN. Okay. No. This is I am cancelling. Okay. This is I am cancelling this option. But we can write it as, this is actually a wrong option, CN. Okay, you can write CN. I am writing here CN. CN. Okay guys, CN. Okay. C and D. Yeah, C and D you will get C and D. Okay. Yes, correct. Okay. Then I will give you break. I will give you break. Now time enna aidichu 1:10 alle 1:30 20 minutes podulla break 20 minutes. Okay, I will tell you, no worries. No worries, I will tell you once again. So inge enna nadandirukkuda, first if you are reacting with HCl vechu react பண்ணும்போது this double bond will break and carbocation will form. Okay, so carbocation will form and inge enna irukku, Cl minus is there. Okay, Cl minus is there, so Cl minus will attach to that carbocation. Okay, Cl minus attach agum. So we know that what is the second step, AgCN is there. Okay, AgCN is there. Okay, if that product react with AgCN means what will happen? So Ag plus Cn minus form agum. So Cn minus la nitrogen enna direct inga enna chlorine replace pannita anga varum. Okay, clear? It is also SN2 reaction. 30 minutes. 30 minutes oda. 30 minutes. 30 minutes romba jaasti illada. 20 minutes podulla. 20 minutes podulla. Yes, is clear, ma'am. Okay. 20 minutes. Allylic position, yeah, it is there, but it's we can consider CN, we can consider directly CN, NC consider pannala. So allylic it's not necessary. Allylic sollave venda. Okay. Okay. It is actually allylic la dhaan irukku. Okay, allylic la dhaan irukku. So CN allylic position la dhaan irukku. So adu avlo important. Inga actually avlo allylic vechu சொல்ல முடியாது நமக்கு. Okay, then questions வேணுமா இல்லனா break வேணுமா? If you want questions I will give you questions, if you want break I will give you break. What do you want? "30 minutes break kada." Break. Okay, I will give you break. Break. Pasikkudu அப்படியா? Okay, no issue. I will give you a break. Okay. So என்னடா இப்போ 1:10 அல்ல. So I will give you 30 minutes. Okay, 30 minutes illa or 25 minutes I will give you. Okay, 30 minutes exam ku appuram I will give you. Okay, so Okay. So 3 o'clock varaikku irukunda class. Maximum 3. Ma'am, I have a long hair as a boy. It is okay with the exam. What should I say da? So if you can cut, just cut it. Or what we can do is like just tie your hair, okay? Tie your hair properly. Okay. Okay. Tie your hair. Okay guys, bye bye. Now perfect allada. Now perfect. Mic ma'am, ayyo. Settle. Settle. Increase mic volume. So I will increase my volume. This is the maximum volume of mic. So I want to increase my volume. Okay. Okay. So here is your next question. It's JEE 2025 question. JEE 2025 question. You can do a try. Okay. It's very easy question. Direct kettirukku. Yes, Asha. It's Asha. A. Why A? Why A is the answer, Ada? Which among the following? Which among the following halide will generate the most stable carbocation in the nucleophilic substitution reaction? Okay. So which one is which halide is most stable? Which one will produce most stable carbocation? Okay. So here also check, not here, it is here. Tell me. Okay, C. So you guys are saying C. And can you tell me the reason also? Here you can see phenyl group, phenyl group, phenyl group. Okay. So 3 phenyl group means, what is that? 3 phenyl group means it's very simple. So you can see 3 ring. Okay. 3 resonance positive. Okay. So here you can see this is not positive. Here. Okay, here it is positive. So that means we can say that 3 resonance ring. Okay, 3 resonance. So I will write resonance. 3 ring. Okay, 3 ring is there. Okay, so ring, number of ring increases means what will happen? Stability, resonance will also increases. So stability will also increases. So the correct answer is 1 only. Okay, so namakku 100 likes aicha. 100 illa 150. 150. I thought it was phosphorus. Phosphorus. pH phosphorus ada. So then you will think it is pH. My kids are so intelligent. My kids are so intelligent. Then I will give you next question. So here is the question. Yes, Hari, good afternoon. Good afternoon. You are coming and you are saying hi. So, and you will say good morning and you will go. You will come again. You will say good afternoon. Then you will go. This is happening here. See, Okay. Okay. Which one is more stable? That is the question. So you are saying C. Which of the following compound will undergo fastest? SN1. Okay, so guys, it's SN2 reaction they are asking. Okay, SN2 reaction. Okay, carbocation, 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 carbocation. Okay, correct carbocation. So now which one is correct answer? Here I can see C is saying. So tell me guys, where is my energetic kitsada? Yes. So we know that it is SN2 reaction. Okay, it is actually tertiary. It is actually tertiary. It is also 1, 2, 3 tertiary carbocation. It is secondary. So we know that guys. So when you consider SN2 reaction, which one is more stable? Primary is more stable, then secondary, then tertiary. Okay, in case of SN2 reaction, okay, in case of SN2 reaction. So what was the correct answer? Correct answer is option C only. Okay, option C is the correct answer. Okay, option C is the correct answer. Then I will give you another question. What happened? Okay, then you can write. Vibgyor love. Yeah, I will. CBSE result ഇതുവരെയ്ക്കും വരില്ല അല്ലേ? Takshin, don't say anything, okay? Takshin, yeah. Okay, da. Okay, I accepted your thank you. Thank you, okay. Takshin, how is your preparation going, Takshin? How is your preparation going? How is your preparation going? How is your preparation going, da? Yes. So here I can see high concentration strong nucleophile reagent. High concentration strong nucleophile reagent with the secondary alkyl halide do not have bulky substituent will follow SN1. Correct. This is correct only. Yes, high concentration and yes, correct only. Bulky substituent. Okay. So less ariko. So a secondary alkyl halide when treated with a large excess of ethanol. Okay, ethanol. OH is there. So SN1 reaction. Yes, correct. Both 1 and 2 is correct. Statement 1 is true but false. 1 is false. No. Both statement 1 and 2 are false. Both statement 1 and 2 are true. Okay. Both statement 1 and 2 is correct only. Okay. Then what is next? Some glitches there. Then we are moving to addition reaction. Okay, we can start. What happened? Hari, you are calling me mom. Am I? Okay. So then we are moving to addition reaction ada. Just a second. Just a okay. There is some technical glitch. Takshin. Addition reaction. Can I call my technicians? It is working now. Now I think it's okay, it's fine. Okay. Yeah. So now we are moving to, yes. So now we are moving to addition reaction. Addition reaction. Okay. Yes, it's perfect now. So addition reaction. Okay. So addition reaction. First I'm going to take electrophilic addition reaction. Okay, electrophilic addition reaction. Okay, so we are classical. There is two type of electrophilic addition reaction. Okay, so first one is we are classical addition, through classical addition, and another is through, where is it, non-classical addition. Okay, so I will tell you in detail. So this is very important. Okay. So yes, addition reaction. So we are first one is we are classical carbocation. Okay. So through classical, yes, that correct. Ravela technical glitch is there. So adanala class start panna mudiyala. So I will take that session tomorrow. Okay da. Okay, got it. So yes, the electrophilic addition reaction. Okay, electrophilic addition reaction. First is one is we are through, that is classical carbocation. Okay, there is two, again it's classified into two type. Okay, one is hydrohalogenation addition, another one is hydration. Okay, hydrohalogenation means hydrohalogenation is just addition of hydrogen and halogen, that is HZ addition. Okay. So next is hydration means addition of watering. Okay, watering acid medium. Okay, addition of water in acid medium. Okay, watering in acid medium. Okay, clear. So here you can see same reaction. Okay, same reaction, same mechanism in the starting time. Okay, starting time in first step it's actually same only. So second step la da enna, two different type of reagents varudhu. Okay, two different type of reagents varudhu. So we can see this is a double bond. Okay, this is a alkene. Okay, this is a alkene. So here you can see H plus. Okay, H plus is there. Then what will happen, Dada? It's very simple. This double bond will break. Okay, this double bond will break and one carbocation will form. Okay, one carbocation will form. Okay, one double bond will break, and or we can say protonation, addition of proton will happen. Okay, protonation will happen. So what will happen? Protonation will happen. So one side la enna nadakunda, one side la hydrogen vandu add agum. So if it is rearrangement possible, okay, if rearrangement is possible, rearrangement will happen, okay. So this is actually ரொம்ப important haloalkanes and haloarenes and electrophilic addition and named reactions. You can expect, I don't know how much questions. So because in every chapter we are covering named reactions, okay. So yes. So what will happen? So this double bond will break and hydrogen when they attach ago. So what will happen? So here what will form? Here carbocation will form. So if rearrangement is possible means rearrangement will also occurs. Okay, if rearrangement is, we know that which carbocation is stable tertiary carbocation is stable. Okay, tertiary carbocation is stable. Oh, just a second So tertiary in the live, I don't know, I don't want to say 4, 5 எனக்கே தெரியாது because எல்லா named reaction இருக்குல்ல, named reactionல இருந்து we can expect more questions, okay. Yes, evening chemistry physics class இருக்கு உங்களுக்கு, okay. So yes, so what will happen this carbocation will form and if rearrangement possible means it will happen and next step la enna nadakkum. So we are treating with, okay, we are treating this carbocation with a halogen, okay. So it's very simple. So what will happen? So inga x varum, okay, inga x varum, simple, okay, inga x varum. So next step la enna nadakkum? So acidic H2O, okay. So what will happen? Here you can see OH minus will come in that cation, okay. So it's depend on the reagent, okay. In the reagent we are taking, அதை depend பண்ணிட்டு தான் இருக்கும், okay. Clear இல்லடா? Clear இல்லடா? After class yes sir, of physics class இருக்கும், okay. So I hope it's clear. Then now we just discuss the mechanism. So mechanismத்துக்கு அப்புறம் என்ன இருக்கு? Important points we should discuss, okay. Important points we should discuss. So the first important point is first carbon formation is, okay. So first carbocation, carbon formation illa actually carbocation formation, okay. First carbocation I will write here. Very mistake. First carbocation formation is actually the rate determining step, okay. That first carbocation form agudilla, rearrangement, before rearrangement, okay, before rearrangement or carbocation form agudilla. So that step will determine the rate of this reaction and rate of the reaction is directly proportional to nucleophilicity of the alkene, okay, nucleophilicity of alkene and it's directly proportional to stability of first carbocation, okay. It is directly proportional to stability of first carbocation. I told you na first carbocation, that means before rearrangement, okay, rearrangement ku before irukra carbocation irukla, that is actually directly proportional to rate of reaction, okay. That is directly proportional to rate of reaction. Next, rate of reaction with respect to hydrogen, okay, with respect to hydrogen. So HI, HBr, HCl, we know this, okay, HI, HBr and HCl, okay, this is very important. Then next one is rearrangement of carbocation occurs. Yes, I told you na. So if rearrangement is possible means rearrangement will occurs, okay. Next we are moving to, I will use this only, okay. So yes, this is the question, you can do one question, okay. Yes, it's a question, you can do one question. Come on, do it. Come on, quick. Durga, like 1 hour முடிஞ்சதுக்கு அப்புறம் தான் வந்திருக்கு துர்கா. Hello Ananya. Come on, what is the answer? It's okay. A, yeah, okay. Okay, let me check. Okay, so the addition of HBr to 1 butene give mixture of product A, B and C. Okay, obviously. So what will be the mixture consists of? Okay, the addition of but 2-ene alle method proper but 2-ene alle but 1-ene no but 1-ene. Okay, this is actually but 1-ene. So but 1-ene la irundhu what is we are getting? But 1-ene la irundhu HBr. Okay, it's treating with HBr which treat பண்ணும்போது what we will get? Yes, we can see first carbocation will form. So I will write here carbocation will form here. In next step la what will happen? So carbocation will form here or carbocation will form here. Two possibilities irukilla, carbocation here or here. Okay, so here or here is there. So enna nadakum? So inga yes. So yes, everyone is saying A only. Okay, so I don't know, let me check. So here there is 2 carbocation form ago. Okay, 2 carbocation form ago. So on the 2 side layum enna bromine varadhukku chances irukku. So 1 bromine here, 1 bromine here. So 1 and 2 yes, 1 2 3 yes, 1 2 1 yes, correct. So there is 2 product. So 2 product varum. So what will be the product? So what will be the product? Yes, and this is actually enantiomers. Okay guys, this is enantiomers. Okay, so this is enantiomers. So A and B is major product and C is the minor product. Correct. So here enantiomers is there. Okay, enantiomers is there. Okay, enantiomers are there. So yes. Then next question. Arrange the following hydrogen halide in order of their decreasing reactivity propane. Okay, so idu already we discussed important points anga sonnumbodhu we already discussed hydrogen with respect to hydrogen, rate of reaction with respect to hydrogen. Okay Manju, clear. Rate of reaction with respect to hydrogen we discussed alle. So appo we discussed all these points. Come on, where is answer? We already discussed it. Where is that point? With respect to hydrogen, Hi, HBr, HCl. Okay, so here you can see which one is correct answer. Which one is the correct answer? Obviously Hi, HBr, HCl. This is the correct answer. Okay, yes, C is the correct answer. Yes, very good, very good. So I can see iodine, bromine. Yes, iodine, bromine, chlorine. Yes. Then here next one is, okay, so we discussed via classical carbocation. Now we are going to discuss about non-classical carbocation. Okay, now we are going to discuss about non-classical carbocation. So here also there is 2 different type of reaction. Addition of hydrogen in invert solvent. Okay, addition of hydrogen in invert solvent, addition of halogen in non-invert solvent. Okay, so we can discuss that in detail. Okay, so here you can see I am taking alkene. So I am taking halogen only. Okay, I am taking halogen only. I will change color. So then I will take white. White is also there. Which color? Then I will take red. So halogen. Okay, it's halogen bond. So this bond will break. One halogen will take that complete electron and it is partially positive and one is partially negative. Okay, one partially positive and one partially negative. So what will happen? That, okay, that halogen, one halogen will attach to one carbon. Okay, then what you will get? Cyclohalonium ion. Okay, you will get a cyclic compound, type of cyclic compound. Okay, halonium ion you will get. So this is a, so double bond will break, okay, double bond will break. So you will get a bond, okay, cyclic bond, okay. You can see a cyclic compound, that is cyclohalonium ion you will get. So if we are treating this cyclohalonium ion with halogen, or we are treating with water and H plus, okay, what we will get? One side la you will, if you are treating with water and H plus, so it will break, okay, this halonium ion will break and OH will attach. So if you are treating with X minus, that means any halogen group, what will happen? So two side la XX varu, okay, two side la XX varu, okay, clear? This is actually non-classical carbocation, okay, we are non-classical carbocation formation, okay. So here also the points are very important. So non-classical carbocation formation is the RDS, that means RDS means rate determining step, okay. So rate determining step and first step is the rate determining, that is non-classical carbocation formation, allada. So here this rate of reaction is directly proportional to, okay, rate of reaction romba chinnada irukku in proportionality. So rate of reaction directly proportional to nucleophilicity of alkene, and it is directly proportional to stability of partial positive carbon, okay, stability of partial positive carbon. Then next one is no rearrangement occurs, there is no rearrangement, okay. Normally we know that carbocation is there, means yeah, rearrangement, tertiary, secondary, primary. So here there is no rearrangement. And next point is cyclic halonium ion formation, okay, cyclic halonium ion is formed, allada. So cyclic halonium ion is forming here, and CCl4 CH2Cl2 can be used as inert solvent. And what is inert solvent? So actually we can say it's it could not react, okay, it could not interfere in that reaction, okay, it could not interfere in this reaction, okay. Or we can say one more point, okay. So the polarity, okay, polarity is actually 0, okay, partial charge, there is no charge and all, so it is actually 0, okay. So that is the reason we can say it is inert solvent, okay, it is inert solvent. And here you can see anti-addition, okay, anti-addition, opposite side la dhaan vandu attack nadakudhu, so it is anti-addition, yes. Thank you so much, your love. Next question is here, okay. Next is a question, identify the major product, Cl2H2, okay. So identify the major product, which one is the major product? So double bond will break, and what that hydroxyl, cyclohydroxyl ion will form. Not clear, ma'am. Okay, I will explain again, okay. So you should say at that time, allada, ipo question aidichilla, so after question I will explain again, okay. B. You guys are saying B. So what will happen? Halonium ion will form, okay. Chlorine da irukku, so chlorine will form, okay. So in water, in presence of water, what will happen? Okay, water oda presence la treat பண்ணும்போது one side la chlorine varum, one side la OH varum, okay. So this side la we can expect OH, okay. So yes, correct answer is this only. Nice. Very good, guys. Then we are moving to named reactions, named reactions, okay. Named reactions are very important. So guys, kaiyila book pen ellame irukkilla, so book pen ellame irukkilla, so named reactions are very important. So we are discussing all named reactions, and if I can't finish all the named reaction, I will conduct one more session, okay. I will conduct one more session for named reaction. Clear? Okay? Do you one or more? Nada, my ma'am question eppadi one or more time? Ma'am question eppadi one புரியல OH எப்படி yes ma'am yes ready OH எப்படி CH2 ல one more time OH எப்படி CH2 ல one more time can you say again Eda, this bond is breaked okay this bond double bond break ஆயிடுச்சு so here what will form so this bond breaked X வரும் next step ல இது X இங்க போகும் இங்க OH வரும் okay clear clear okay then so named reaction la like ungaloda textbook la named reaction most of the named reaction ku yes most of the named reaction ku enna illa like mechanism is not necessary okay most of the named reaction okay so in your NCERT if named reaction is there NCERT okay NCERT la named reaction oda mechanism irunda I will explain okay so most of the named reaction if you consider all the named reaction in NCERT books like almost 90% illana 80% ku there is no mechanism is necessary okay it is no just directly you can apply and you can write okay but in case of some reaction okay in case of some reaction they already given the mechanism and all okay that we will discuss here okay that we will discuss here so here is the first reaction that is Wurtz reaction okay first reaction is Wurtz reaction so here you can see RX okay RX is there so RX is reacting with Na sodium Wurtz reaction means so alkyl halide okay alkyl halide is reacting with the sodium in dry ether okay alkyl halide idu madri we have one more equation that is Grignard reagent irukla so Grignard reagent madri oru equation okay so that is Wurtz reaction so here we should take 2 alkyl halide this is very important okay 2 alkyl halide then what will happen it's very simple so here free radical will form here also X free radical okay it's free radical it's not necessary so we can take 2 free radicals okay alkyl free radicals will form then it will couple okay it will couple and you will get alkyl group okay so here you can expect only even number of carbons okay only even number of carbons okay so only even number of alkyl group you will get okay only even number of carbon containing alkyl group you will get and this alkyl group is actually symmetrical because here you can see two same alkyl groups are combining okay so two same alkyl groups are coupling so what will happen obviously you can see symmetrical alkene then there is no methane formation okay there is no methane formation ada methane eppadi irukano inga it's actually two alkyl group is coupling okay at least you will get two that means ethyl group okay so ethane is the like if you are starting from alkyl product means at least you will get ethane okay you will get ethane you will get okay yes so methane formation is not possible in Wurtz reaction this all these points are very important okay all these points are very important okay so yes I have written all these points then next is decarboxylation okay decarboxylation reaction what is decarboxylation reaction tell me guys what is decarboxylation reaction quickly what is decarboxylation reaction parayada sollada so what is decarboxylation listen carefully decarboxylation means removal of CO2 okay removal of CO2 here okay here it is CO2 okay so what will happen dada so what will happen inga irundha CO2 will go so you will get RH in presence of the reagent is very important okay in presence of Na not carbon and CO2 okay CO2 okay not COOH okay CO2 decarboxylation okay clear so here the reagents are NaOH and CaO, okay. So we are heating, okay. So if you combine these things, you will get soda lime, okay. Soda lime, if you are heating this reagent, we can eliminate, okay. We can eliminate, we can remove CO2, yes, CO2, yes. Next, Kolbe's electrolysis. What is Kolbe's electrolysis means? So it's also very simple reaction, and it's also very important reaction. Here also you should take two sodium salt of acetic acid, okay, sodium salt of carboxylic acid, I am saying acetic acid, sodium salt of carboxylic acid, here you can see. So what will happen? This bond will break. So R free radical you will get, okay, you will get two free radical. So R free radical and R free radical combine pannittu you will get RR, you will get alkyl group, okay. Is it clear? So Kolbe's electrolysis. What is the reagent in this reaction, Ada? What is the reagent? What is the reagent in this reaction? Tell me, what is the reagent, Ada? What is the reagent in this reaction? What is the reagent in this reaction? What is the reagent in this reaction? Free radical is the reagent, Ada. Free radical, reagent. So, Ada, it is electrolysis, electricity. Okay, electricity, we need electricity, Ada. So, we are using electricity. Okay, we are using electricity. So, here mechanism is necessary in this reaction. Okay, mechanism is necessary in this reaction. So, we know that I am taking two water, it's like, it's a aqueous solution, okay, it's a aqueous solution of carboxylic, sodium salt of carboxylic acid. So, we know that water, 2 moles of water and sodium salt of carboxylic acid also we are taking 2. Then what will happen? So, you will get Na plus, okay, you will get Na plus. So you will get 2 Na plus, okay, you will get 2 Na plus, 2H plus, 2OH minus, okay. So what will happen? It's a electrode is there, okay, anode is there, cathode is there, okay. So it is a electrolysis process, allada. So anode is there, cathode is there, then what will happen? So in anode, okay, in anode 2RCOO minus, okay, 2RCOO minus. So anode le enna irukunda anions, okay, anions will come in anode, okay. So anode la who will come? So anions will come. Anions na enna negative charge. So it is negative charge. So anions la vandirukku. Okay. Then what will happen? It's very simple. This bond will break. Okay. This bond will break. So here you can see it will form CO2. It will form CO2 and this free radical. Okay. This free radical will form R2. Okay. This free radical will form R2. Okay. Clear? In cathode la what you can see? Anode la anion, cathode la cation, alle. So cathode la cation. Okay. I am teaching organic only, I am teaching organic only. So here in cathode you can see cations, okay. In cathode you can see cations are there. So, cation na ennada? Positive charge. What is positive? Positive inga enna irukku? Positive inga H plus irukkula. H plus is there. So, what will happen? So, inga irundhu 2 electron release pannirukku. So, that hydrogen will accept 2 electron. Okay, hydrogen will accept 2 electron and it will form hydrogen gas and it's evolved from here. Okay, hydrogen gas will evolve from this like container. Okay, container la irundha adu evolve agu. Okay. Okay, clear? So, my next question, okay, my next question. So, they will ask this type of question, okay, they will ask this type of question where you can see where hydrogen gas will produce, okay, in cathode or in anode, okay, this type of question you can expect, okay, in cathode or anode where you can see hydrogen gas, okay, where you can see hydrogen gas in cathode, okay, in cathode the hydrogen gas will evolve in cathode only. Next is alkene CO2 evolved at the anode. Okay, so they will ask, so in an anode la what things you can see. Okay, in a product anode la form agu alkene. Okay, so you can see alkene is there. Okay, it is alkene ada. Alkene will form in anode. Okay, anode la enna form aguda alkene will form, and anode la enna evolve agudhu, anode la CO2 evolve agudhu and alkene form agudhu. Okay, clear? I hope it's clear. So next enna H2 enga evolve agum, I told you na, it's at a cathode. It's at cathode. So nature of solution. What is the nature of solution? Can you tell me what is the nature of the solution? Tell me. What is the nature of the solution? What is the nature of the solution, Ada? What is the nature of this solution? What is nature? Is it acidic or basic? That is the point, okay? Is it acidic or basic? Obviously, you can see sodium is there. Where is sodium? Yeah, sodium. Sodium will combine with OH. So, what you will get? Sodium, NaOH. So, NaOH means obviously it is basic. Okay, solution after this electrolysis, what you will get? No, not acidic. You will get basic. Okay. Nature means acidic or basic. Okay, that I asked. Okay. So, you will get basic. Okay, you will get not acidic. You will get basic. Okay. Clear. So, here you can see Na is there, OH is there, Na and OH combine pannite, you will get NaOH. Okay. I hope it's clear. I hope it's clear. Then I will give you a question. So quickly, tell me quickly, enakku kadachachu question, answer. So yes, tell me. Yeah, doubt irukka? Why doubt? Correct, no doubt. So alkyne containing even number, obviously even number dhaan varum. Okay, even number of carbon atom are prepared. Yes, there is a mistake. Inga oru mistake irukku. Here it's mentioned alkene. No, it's alkane only. So na adu paatha ingiyum potirukku. Okay, it's not alkane. That's not alkene. Alkane da irukku. Okay. So, prepared second enada sodium and potassium salt of carboxylic acid taken as substrate. Yes, sodium and potassium salt da we are taking illada. So, correct, adum correct. H2 gas is deposited at anode, no cathode. So, this is wrong. 1 and 2 is correct. Then I will give you next question. Illa. Next we are moving to next named reaction. Okay, Birch reduction. Okay, Birch reduction. So, Birch reduction, let's say what is happening in Birch reduction ada. So, it's very simple. Alkyne la irundhu we are preparing transalkene. Listen, transalkene. Okay, from alkyne we are preparing transalkene. Guys, what is transalkene? So, we know that cis is there, trans is there. Okay, cis na same side la varum. Okay, so group same side la, same group same side la vanda, it is cis. Trans na same group different side la vanda, opposite side la vanda, that is trans. Okay, from Birch reduction you will get transalkene. From Birch reduction you will get transalkene. Okay, so come on, alkyne irukku. So alkyne is a triple bond. So what will happen? This bond will break. Okay, only one pi bond will break. Okay, okay, one pi bond will break and in a two side liyu hydrogen varum. Okay, two side liyu hydrogen varum. So here the reagent is very important, liquid ammonia and sodium, okay. Sodium and liquid ammonia is the reagent, okay. Sodium and liquid ammonia is the reagent. So here you are getting trans, okay, trans. So alkyl group and here alkyl group. Here hydrogen, hydrogen. Opposite side la hydrogen, hydrogen is there. Alkyl group may be changed, okay. Hydrogen we can consider. Hydrogen, hydrogen opposite irukku, so it is trans. Is it clear, guys? Hydrogen, hydrogen opposite varudhu, add pandra hydrogen, hydrogen is coming in opposite side, so it's trans. Clear ada? Next we are moving to ozonolysis. Ozonolysis theriyumla veedu madri, veedu like that is actually ozonolysis. So ozonolysis when you consider, so it is two type, okay, like one is reduction and another one is oxidation. So when you consider reductive ozonolysis, okay, when you consider reductive ozonolysis, O3 and CCl4 is necessary, okay, O3 and CCl4, okay, O3 and CCl4. So here you can see zinc or zinc H2, zinc in water, okay, zinc in water, that we are taking as a reagent, okay, reagent, okay, or dimethyl sulfide also we can take it as a reagent in reductive ozonolysis. So when you consider oxidative ozonolysis, so here we are taking ozone and CCl4, okay, CCl4 and hydrogen, water and hydrogen peroxide, okay, hydrogen peroxide and water. Next, here also we can take it as KMNO4, illana K2Cr2O7, okay, hot condition la acidic KMNO4 and acidic K2Cr2O7 eduthalu we can do oxidative ozonolysis. Clear? So this reagent is very important, okay da. Adanal I am giving a separate page for reagent, okay, ozonolysis or reagent, okay. Okay, then we are moving to reaction. What is happening here? I will tell you. Here I will use, okay. We are taking an alkene, so this is a alkene, okay. First we are discussing about reduction. What will happen? Reduction, yeah, simple da, this bond will break. So what will happen? Oxygen, addition of oxygen, so it's complete, it's not double bond, it's complete bond will break. What you will get? So you will get, the product will be C, this will be your product, okay, this will be your product, okay. In ozonolysis, which one? Reductive ozonolysis, okay. In ozonolysis, which ozonolysis? Reductive ozonolysis, okay, reductive ozonolysis, okay. Clear alla? So reagent, we know the reagent allada, we already discussed the reagent, okay. So reagent enna inga already discuss pannirukku, edachu reagent edutha podum, okay. Next is oxidative ozonolysis, okay. Oxidative ozonolysis la enna nadakudhu, same thing will happen oda, okay, same thing will happen, but again enna oxidation nadakum. So I will draw here ozonolysis in oxidative ozonolysis, okay. Okay, oxidative ozonolysis la enna nadakudhu, it's very simple, same thing, okay. So here I am taking C double bond C, here also it is there, okay. So what will happen at our first reaction if you are taking means, so C double bond O plus C double bond O. Okay. So first reaction அப்படியே நடக்குது. Second stepல because இங்க என்னன்னா we are using here you can see the oxidizing agents. Okay, agents are very strong. If you are taking KMNO4 and K2Cr2O7, C double bond O is forming there. So C double bond O is forming there. So what will happen? So it's reacting with the KMNO4 நடக்கும்போது KMNO4 ஓட presenceல what will happen? It will become carboxylic acid. Okay, it will become carboxylic acid. Appo RCOOH. Okay, it will become carboxylic acid. And here what will happen? In presence of H2CO3. Okay, in presence of H2CO3 la inga enna nadakudada? Inga what you will get? You will get here also C double bond O and two side la hydrogen varudhu. Okay, two side la hydrogen varudhu. Okay, clear? Hydrogen வருது. clear doubt இருக்கா? clear named reaction clear So next we are moving to next name reaction, that is Kulchoff reaction. Okay, Kulchoff reaction. Yes ma'am, excess oxygen is oxidative oxygen. This is ozonolysis. So and the oxidizing agents are also very strong. Simple. So yes, so here also we are treating triple bond. Okay, triple alkyne. Okay, alkyne in a dilute H2SO4 or dilute AgSO4 or ivide inga Hg2 plus. Okay, Hg2 plus and water oda presence la reaction nadakudhu. Okay, Hg2 plus and water oda reaction presence la reaction nadakudhu. And here what is happening? Simple ada, you know, tautomerism. You know guys, tautomerism. Tautomerism will happen here. Okay, so here double bond enna irukku? So double bond la irundhu this bond will break up, anga irundhu inga varum. Appa double bond la irundhu idu double bond agum and inga OH bond irukla, OH bond. So this hydrogen will go this side. Okay, so hydrogen inga pogum, appa HCH3 ah marum. So tautomerism. Okay, tautomerism. Okay, yes, tautomerism. Yes sada, correct. Okay, then we are moving to next reaction. This is Friedel-Crafts alkylation reaction. Okay, Friedel-Crafts alkylation reaction. Okay, so here benzene is treating with the RCl. Okay, RCl in anhydrous aluminium chloride oda presence la. Okay, so what will happen? Simple ada. So here this RCl irukla, so that bond will break, you will get R plus and Cl minus. If rearrangement is possible in this carbocation, so rearrangement will happen, so that carbocation will attach to benzene. Okay, clear? That is Friedel-Crafts alkylation reaction. Okay, Friedel-Crafts alkylation reaction. Next is Friedel-Crafts acylation reaction. Okay, Friedel-Crafts acylation reaction. Okay, so here we are taking same benzene. So here we are taking RCOCl. Okay, anhydrous aluminium chloride oda presence la. So what will happen here? It's very simple. So inga irundhu enna add agum? Inga just a second ada. Yes, so inga COR varum. Okay, COR attach agum, chlorine inga irundhu pogum, COR varum. Okay, COR oda presence la dhaan nadakudhu. So COR inga C minus OC OCOR. Okay, so OCOR varum. So OCOR oda next step la enna nadakum? So idu C double bond O irukla, C double bond O. So we can say that oxygen contain lone pair of electron. Okay, oxygen la enna irukda? Lone pair of electron irukku. So carbon mele enna irukku? Carbon mele vacant because carbocation illa. So you can see back bonding. Okay, back bonding will happen. So here there is no resonance, but back bonding is there. Okay, back bonding is there means it's more stable. Okay, back bonding is there means it's more stable. So in the carbocation directly inga poi benzene mele poi attach agum. Okay, in the carbocation directly benzene mele poi attach agum. Clear? I hope it's clear, guys. Clear? Then next, so you will get aromatic ketone. Okay, so you will get aromatic ketone. So next is Lucas test. So tell me, guys, what is Lucas test? Tell me what is Lucas test? So you know Lucas test, Lucas reagent. So tell me what is Lucas test and Lucas reagent in the chat box. So what is Lucas test and what is Lucas reagent? What is Lucas test and what is Lucas reagent? Tell me quickly. Lucas test, it is the test for alcohol to identify primary, secondary and tertiary alcohol. Okay. Lucas reagent is zinc chloride only, zinc chloride, ZnCl2. Ramesh, I will tell you again. Okay, after this I will tell you. Okay, so I will tell you that again. So it's very simple da. So enna nadakudhu inga RCOO inga O irukla, O minus. So idum venda, just consider pannadinga. RCO irukku, idu அப்படியே போகும் இங்க இருந்து. Okay, இது அப்படியே போகும். So it will form carbocation. Okay, இந்த group அப்படியே போகும். Okay, COOR group இங்க இருந்து போகும். Okay, COOR group இங்க இருந்து போகும். Actually that I will tell you. So எங்க இருந்து COOR group வந்திருக்குன்னு ஒரு confusion இருக்கும்ல. That I will tell you again. Inga we are using two group. Okay, two group. Okay, RCOCl minus oda we are taking 2. Okay, so adu coupling nadakudhu, combine agudhu. Okay, adu combine agudhu. So inga irundhu enna pogunda, in the complete group pogum. Okay, in the complete group inga irundhu pogum. So what you will get at last, you will get this. So here you can see back bonding. We already discussed in GOC la already discussed panni irukku. So back bonding is more stable. Okay, back bonding is more stable. So here you can see back bonding is there means vacant orbital is there in carbon. Okay, vacant orbital irukku. Oxygen mele enna irukku? Oxygen contain lone pair of electrons. So that lone pair is ready to give. Okay, oxygen is ready to give that lone pair to carbon. Okay, so yes, what is that? It is back bonding. So back bonding means it's more stable. Okay, when you consider back bonding and resonance, back bonding is more stable. Okay, so அப்படியே அது வந்து attach ஆகும், அவ்வளோதான். You will get aromatic ketone. So tell me, guys, yeah, நம்ம என்ன சொல்லிருக்கு? Lucas reagent. What is actually Lucas reagent? Concentrated HCl and anhydrous zinc chloride is actually Lucas reagent. Okay, so Lucas reaction னு சொன்னா என்ன? Primary, secondary and tertiary alcohol identify பண்றதுக்காக இல்லனா differentiate பண்றதுக்காக we are using this Lucas reagent. So we are taking 3 alcohols. Okay, so I am adding all in 3 alcohol, 3 different alcohol, primary, secondary and tertiary alcohol. I am going to add a Lucas reagent. Okay, then what will happen? So in tertiary alcohol you can see a immediate turbidity. Within seconds you can see the turbidity. Okay, in secondary alcohol it will take time. Okay, maximum 5, like 1 to 5 minutes it will take time, and you can see turbidity in secondary alcohol also. When you consider primary alcohol, there is no turbidity in primary alcohol. Okay, there is no turbidity in primary alcohol. Okay, clear? So if you are heating the primary alcohol, okay, if you are heating the primary alcohol, that mixture, okay, primary alcohol and Lucas reagent mixture, if you are heating, then you can see turbidity. Okay, you can see turbidity. So ROH in a concentrated HCl and anhydrous zinc chloride இருக்கும்போது what you will get RCl கிடைக்கும். Okay, OH replace பண்ணிட்டு அங்க Cl வரும். Clear? Clear? Clear, clear, clear. Okay. So next we are moving to next one. Dawson's reaction. Ennada Dawson's reaction. Oru 5 minutes I will come. Okay, just a second. 5 minutes. I'm back. ஒரு 5 minutes தானே கேட்டது. Yes, 5 minutes ஆகல, 3 minutes தான் எடுத்திருக்கு. 3 இல்ல 2 minutes. Okay, come on guys. Dawson's reaction. Okay, what is Dawson's reaction? Here you can see our same alcohol we are taking. Okay, in presence of thionyl chloride we are treating alcohol. So what we will get here? We will get alkyl chloride. Okay, alkyl chloride oda production da actually Dawson's method, and this method is actually very good. Okay, it's a very good method to prepare alkyl chloride. Why? Because here the byproduct you can see SO2 minus SO2 and HCl. Okay, both are in gaseous state, so it will escape. It will escape. Okay, adu escape agum inga irundhu. So here ROH and Cl SCl. So idu break agum. So here you can see this bond will form. Idu complete SO2 amaru. Enga poi SO2 again SO2 amaru. So idu HCl amaru. Okay, yes, clear ada? Clear? Dawson's reaction is clear alle. Then we are moving to Finkelstein reaction. Okay, Finkelstein reaction na enna? So here we are treating with the sodium iodide. Okay, enna kadikkiradhukaga we are doing this reaction. So for alkyl iodide oda formation ku. Okay, alkyl iodide oda formation da enna Finkelstein reaction. Okay, alkyl iodide. So here you can see alkyl halide. Okay, maybe halogen is chlorine or bromine. Okay, here we are taking halogen is chlorine or bromine, alkyl chloride or alkyl bromide. So here we are treating this alkyl chloride or alkyl bromide with the sodium iodide. Okay, so sodium iodide in presence of acetone, and what will happen? You will get Ri. Okay, Ri and NaX. NaX is not necessary. Okay, NaX, sodium bromide or sodium chloride. Okay, so yes. Then we are moving to Swarts reaction. Okay guys, we are moving to Swarts reaction. What is Swarts reaction? Swarts reaction na ennada? So Swarts reaction la Rx is there. Okay, we are preparing in Swarts reaction, we are preparing alkyl fluoride. Okay, alkyl fluoride from alkyl chloride, alkyl bromide or alkyl iodide la irundhu we are preparing alkyl fluoride. Okay, alkyl fluoride we are preparing. So here we can use metal fluorides. Okay, any one of the reagent you can use. Okay, metal fluoride. Okay, AgF is there, SbF3 is there, COF2 is there. Okay, so different type of fluoride, metal fluorides are there. I will finish. Okay, I will finish the session at 3 o'clock. Okay, break edukku. Okay, so you will ask a break only. I can see your answers. I can see that you are asking break. So what you will get? You will get metal alkyl fluoride. Okay, alkyl fluoride you will get. Okay, next only next is diazotization. Okay, diazotization la. So here we are taking aniline. Okay, aniline in a sodium nitrate oda presence la treat பண்ணும்போது, yes, sodium nitrate oda presence la HCl oda presence la treat பண்ணும்போது in presence of 0 to 5 degrees Celsius temperature la treat பண்ணும்போது what we will get? We will get, so enna nadakkum? So this is diazonium salt. Okay, you will get diazonium salt. Okay, so clear. So next that is diazotization reaction. Next is Sandmeyer reaction. Okay, so you will get diazonium salt. Here we are taking here we are taking HCl. So you will take diazonium chloride. Okay, so diazonium salt you will get in this reaction. So here we are taking chlorine. So you will get diazonium chloride. Okay, you will get diazonium chloride. Next we are using that diazonium chloride. Okay, we are using that diazonium chloride, and this is Sandmeyer reaction. Okay, we are treating in different conditions. Okay, in different reagent and different condition. So here it is copper Cu2 Cl2. Okay, in presence of HCl what you will get? So anga chlorine varum. So if you are treating with a Cu2 Br, okay, HBr, what you will get? So it's Cr2 Br2 ada. Cr2 Br2. So what you will get? You will get bromine varum. So if you are treating with the CuCN, okay, CuCN in presence of KCN oda presence la treat பண்ணும்போது what you will get? CN varum. Clear ah? இது clear ah? இது வரைக்கும் doubt இருக்கா? Okay, CN, yes, CN, cyanide you will get. Okay, so next I think okay, then we can finish. Next reaction start panna, it will take like almost 15-20 minutes mele edukunda. So I will finish now then. Okay, almost next reaction ku like explain pannanona we need more time ada. So I want to finish the class at 3. Okay, அதுக்கப்புறம் லெரின் மேமோட கிளாஸ் இருக்குது. ஓகே, லெரின் மேமோட கிளாஸ் இருக்குது. உங்களுக்கு லெரின் மேமோட கிளாஸ் எப்போ இருக்குது? ஸோ எவ்வளோ லைக் ஆகிடுச்சு? 126, 150 வேணும்ல. ஸோ எல்லோரும் சீக்கிரமாக லைக் பண்ணுங்கள். ஸோ லெரின் மேமோட கிளாஸ் இருக்குது உங்களுக்கு. So okay, so I hope இது கிளியராக இருக்குன்னு நினைக்கிறேன். ஓகே, பை பை. So I will give you part 2. Okay, I will do part 2 for named reaction. Okay, I will do part 2 for named reaction. Okay, I will do part 2 for named reaction. இப்போ complete named reaction cover பண்ண முடியல. I will do one more part. Okay da, named reaction ஓட one more part I will do. Okay, I think 4:30 da, 4:30 க்கு லெர்ன் மேமோட கிளாஸ் இருக்கும். ஓகே ma'am, will you continue tomorrow? I will continue that. I will tell you, actually tomorrow உங்களுக்கு complete கோபிகா மேமோட கிளாஸ் இருக்குது. ஓகே, மார்னிங் டு ஈவினிங் கோபிகா மேமோட கம்ப்ளீட் பயாலஜியோட ஒன் ஷாட் போகுது. ஓகே, ஸோ எல்லோரும் ப்ராப்பராக ஜாயின் பண்ணுங்கள். அதில் மோஸ்ட் ஆஃப் த பயாலஜி கண்டென்ட், இம்பார்ட்டன்ட் கண்டென்ட் எல்லாமே மேம் என்ன எக்ஸ்பிளைன் பண்ணும். ஸோ எல்லோரும் ஷார்ப் டைமுக்கு ஜாயின் பண்ணணும். ஸோ அதுக்கப்புறம் என்னோடய கிளாஸ் 30th இருக்குது. ஓகே, என்னோடய கிளாஸ் 30th இருக்குது. ஸோ கம்ப்ளீட் கெமிஸ்ட்ரி கிளாஸ் உங்களுக்கு 30th கிடைக்கும். ஸோ இன் பிட்வீன் தட் ஐ வில் கிவ் யூ ஒன் நேம்டு ரியாக்ஷன் செஷன். ஓகே, இன் பிட்வீன் தட் ஐ வில் கிவ் யூ இதோட செகண்ட் பார்ட். ஓகே, 30th that I want to think. So I will give you morning. Okay, maybe May 1. Okay, May 1 I will give you. Okay, May 1 I will give you. Timing please. May 1 I will give you down. Okay. So yeah, I hope it's clear. So timing also. Timing I will inform. Okay, I will put a shorts. Okay, I will upload a shorts. No worries. So okay, thank you so much. So இது maximum practice பண்ணுங்க. So named reaction எல்லாம் ரொம்ப simple தான். Because அதோட mechanism is very less. Okay, mechanism இல்லைன்னா actually it's very simple to study. Okay, so if mechanism is there means rearrangement is there, that is there, this is there. So cation will form, some free radicals will form, coupling will happen. Okay, so if mechanism, when you consider named reaction, it's very easy to learn. Okay, so உங்களுக்கு ஈஸியாக லேர்ன் பண்ண முடியும். பிகாஸ் என்ன, there is no mechanism means we can easily learn அல்லடா. So yes, I hope it's clear. So bye bye. Bye guys.